before there were galaxies swirling like cosmic pinwheels, before stars were born screaming into existence, before atoms even bothered to show up to the party, there was nothing. Not the peaceful, Zen kind of nothing, more like the raw, silent, unknowable absence of everything. No light, no sound, no space, no time. Just the great cosmic zero, holding its breath. And then, boom! The universe didn't politely ease into being. It detonated into existence with all the subtlety of a billion supernovas having a group therapy breakdown. From that impossible flash of birth, space began stretching, time unspooled like a messed-up ribbon, and matter started forming itself out of energy like it had somewhere to be. Your entire reality, from the atoms in your bones to the phone in your hand, is built on the aftershock of that moment. Hey, traveller, pull up a chair, well, a metaphorical one, since chairs are tiny mortal things, and we're about to zoom far beyond IKEA territory. We're diving headfirst into 300 strange, mind-warping, reality-bending facts about the universe. You're not just a spectator. You're a temporary arrangement of stardust about to learn what your atoms have been up to since the dawn of time. We're about to wander through galaxies that behave like drunks, planets made of diamonds, stars that can vaporize you before your last thought loads, and cosmic phenomena that don't care about your rent, your ex, or your sleep schedule. So take a breath, preferably before we head somewhere without oxygen, and settle in. The universe doesn't come with a handbook, but this script, it's the next best thing. Before there were galaxies swirling like cosmic pinwheels, before stars were born screaming into existence, before atoms even bothered to show up to the party, there was nothing. Not the peaceful, Zen kind of nothing. More like the raw, silent, unknowable absence of everything. No light, no sound, no space, no time, just the great cosmic zero, holding its breath. And then, boom! The universe didn't politely ease into being. It detonated into existence with all the subtlety of a billion supernovas having a group therapy breakdown. From that impossible flash of birth, space began stretching, time unspooled like a messed-up ribbon, and matter started forming itself out of energy like it had somewhere to be. Your entire reality, from the atoms in your bones to the phone in your hand, is built on the aftershock of that moment. Hey, traveller, pull up a chair. Well, a metaphorical one, since chairs are tiny mortal things and we're about to zoom far beyond IKEA territory. We're diving headfirst into 300 strange, mind-warping, reality-bending facts about the universe. You're not just a spectator. You're a temporary arrangement of stardust about to learn what your atoms have been up to since the dawn of time. We're about to wander through galaxies that behave like drunks, planets made of diamonds, stars that can vaporize you before your last thought loads, and cosmic phenomena that don't care about your rent, your ex, or your sleep schedule. So take a breath, preferably before we head somewhere without oxygen, and settle in. The universe doesn't come with a handbook, but this script is the next best thing. Let's start at the obvious. The universe is old. Not my back hurts when I wake up old. Not your neighbour still pays bills at the post office old. We're talking 13.8 billion years of pure, uninterrupted existence. For nearly 14 billion years, this cosmos has been expanding, experimenting, exploding, and occasionally forming planets where people argue on the internet. To put that into perspective, if the entire age of the universe were compressed into a 24-hour day, humans would show up at 11:59 p.m. and 59 seconds, and then immediately start complaining about traffic. Earth itself is only about 4.5 billion years old. That means, for the first 9 billion years, the universe existed without your planet, your selfies, or your favorite snacks. And here's the cosmic kicker. The universe is still expanding, not gently, not politely. It's ballooning outward as if it's trying to ghost its own past. Galaxies are sprinting away from each other, some faster than the speed of light. Not because they're breaking physics, but because space itself is stretching in every direction like it's late for work. But let's go even earlier. In the first fraction of a microsecond after the Big Bang, the universe wasn't made of stars or planets. It wasn't even made of atoms. It was just a violent soup of subatomic particles zipping around in a cosmic rave at temperatures so insane they make the sun look like a lukewarm bath. Then came cosmic inflation, that bizarre moment when the universe expanded faster than you can refresh your Wi-Fi. In less time than it takes you to blink, the universe grew from smaller than a proton to something the size of a grapefruit, or a house, or a galaxy, depending on who you ask. Point is, it got big, fast. About 3 minutes after the Big Bang, things calmed down just enough for the universe to start making its first building blocks, the lightest elements. Hydrogen and helium, with a dash of lithium, were forged in those first moments. That's right, the same hydrogen in your water bottle and helium in your birthday balloons started forming 3 minutes after time itself said action. After that, the universe went dark, and not metaphorically. There were no stars yet, just endless hydrogen and helium swirling around waiting for something dramatic to happen. This period is ominously called the Cosmic Dark Ages. No light, no galaxies, no planets, no Instagram. It took hundreds of millions of years for gravity to get its act together. Clouds of gas began collapsing inward, pulled by their own mass, crushing themselves tighter and tighter until the pressure lit the first stars like cosmic matches. Those first stars were massive, chaotic monsters, many times larger than our sun. They burned fast, died young, and exploded in spectacular supernovas. But in those blazing deaths, they forged the heavier elements: carbon, oxygen, nitrogen, iron, the stuff your blood, bones, and iPhone are made of. Every atom in your body heavier than hydrogen was cooked up inside a star and blasted into space when that star died. That means you're not made of Earth stuff. You're made of recycled star guts. Congratulations, you're cosmic compost. Here's something wild. Everything you've ever seen, planets, stars, galaxies, people, dogs wearing sunglasses, makes up only 5% of the universe. The rest is made of mysterious things we can't see and don't fully understand. About 27% is dark matter, an invisible substance that holds galaxies together like cosmic duct tape. And 68% is dark energy, the force responsible for accelerating the expansion of the universe. So yeah, 95% of the universe is basically a locked room with the lights off, and we're poking around trying to guess what's inside. Even the nearest galaxy to us, Andromeda, is about 2.5 million light-years away. That means if you hopped on a spacecraft traveling at the speed of light, which you can't, but let's pretend, it would still take you 2.5 million years to get there. That's longer than humans have existed as a species, and that's just the nearest major galaxy among the 2 trillion galaxies estimated in the observable universe. Not stars, galaxies. Each galaxy has hundreds of billions of stars, many with their own planets. So if you've ever looked up and thought, are we alone? The universe just leaned in and laughed. Even with our best telescopes, we can only see about 46 billion light-years in any direction. Not because that's the edge of the universe, but because that's as far as light has had time to travel since the Big Bang. Beyond that, could be more galaxies, could be infinite void, could be a cosmic Taco Bell. We simply do not know. One of the strangest things Einstein showed us is that time isn't universal. It's bendable, stretchable, and downright moody. The faster you move, the slower time passes for you. The stronger the gravity around you, the slower time flows. That means if you live near a black hole, which I don't recommend, you'd age slower than your friends back on Earth. The universe doesn't just bend space, it bends time like it's soft cheese, and yet, despite unimaginable distances, violent stellar births, exploding stars, collapsing galaxies, and cosmic radiation that could zap you into oblivion, life appeared. On a tiny blue rock orbiting an average star in a perfectly unremarkable galaxy. You're not just in the universe is in you. But let's zoom in on that tiny blue rock you're currently clinging to. Earth didn't show up early to the cosmic party. It formed about 4.5 billion years ago from dust and gas swirling around a newborn sun that was still figuring out how to shine without exploding. The early solar system was basically a demolition derby in space, where rocks the size of countries slammed into each other at tens of thousands of miles per hour. One of those impacts was so massive it knocked a chunk of Earth into orbit, and that rubble eventually became the Moon. Yes, the Moon is basically Earth's scar tissue, floating up there pretending to be romantic. Back then, Earth wasn't the blue paradise you see on postcards. It was a hellish fireball of molten rock, steam, volcanic tantrums, and asteroid assaults. If you'd visited during its first few 100 million years, you would have melted, then caught on fire, then probably melted again. Yet somehow, through cooling, volcanic outgassing, and a ridiculous stroke of cosmic timing, oceans formed. Water collected, temperatures stabilized, and chemistry started flirting with biology. And then something outrageous happened. Life. Not animals with eyes and opinions, but microscopic organisms clinging to rocks and burping out oxygen like it was a side hustle. They weren't glamorous, but they were persistent, slowly terraforming the planet over billions of years. The oxygen they exhaled ended up building the atmosphere you're breathing right now, so every breath you take is essentially recycled microbe farts from deep time. You're welcome. While Earth was busy inventing survival, the rest of the universe did not slow down for applause. Stars kept popping into existence, burning through their fuel and dying dramatically. Some stars go quietly, fading into white dwarfs like exhausted grandfathers. Others go out with a bang, literally, as supernovas. When a massive star dies, it doesn't whisper goodbye. It explodes so violently it briefly outshines an entire galaxy. That explosion scatters heavy elements, gold, uranium, iron, into space like cosmic confetti. Every ring, building, and bloodstream owes its existence to stars that blew themselves apart in acts of spectacular self-destruction. And just when you think stars can't get any weirder, enter the neutron star. It's what's left when a star too big to become a white dwarf, but too small to become a full black hole collapses on itself. Imagine something heavier than our sun, crushed into a sphere the size of a city. A teaspoon of neutron star material would weigh more than Mount Everest. If you tried to take a bite, your jaw, and the rest of your skeleton, would disintegrate faster than your willpower at a dessert buffet. But neutron stars have a crazy cousin, the pulsar. These are neutron stars that spin so fast they shoot beams of radiation into space like cosmic lighthouses on caffeine. Some spin hundreds of times per second. If Earth rotated that fast, you'd fly off the planet so hard you'd land in another galaxy and still be confused. Even stranger than neutron stars are black holes, the universe's way of saying, what if gravity got drunk and broke reality? When a very massive star collapses, it doesn't stop at being dense. It keeps going until all its mass is crammed into a single point with infinite density, called a singularity. Around it is the event horizon, the invisible boundary where even light can't escape. If you cross it, congratulations. You're now part of the black hole's memoir. Time itself behaves differently near a black hole. Get close to the event horizon, and seconds for you might be years for someone watching from a distance. That means, theoretically, you could dive near one, come back out, and find out your friends have grandkids, and your apartment is now a laser tag arena. And black holes aren't just solo acts. There are stellar black holes, intermediate ones, and the ultra-chunky, supermassive black holes that lurk at the center of galaxies. The one in the middle of our Milky Way is called Sagittarius A star, and it's about 4 million times the mass of our Sun. Picture a monster so massive it holds an entire galaxy together while silently judging everything inside it. Speaking of galaxies, let's talk about your address, the Milky Way. It's a spiral galaxy roughly 100,000 light-years across, with somewhere between 150 and 400 billion stars. And drifting among them are likely trillions of planets. Your solar system lives in one of its quieter suburbs, far from the chaotic, star-crushing core. You're not downtown. You're in cosmic middle management. But your galaxy is not alone. It's part of a neighborhood called the Local Group, which includes Andromeda, the Triangulum Galaxy, and dozens of smaller ones. Andromeda, by the way, is actually headed straight toward us. In about 4 billion years, it'll collide with the Milky Way in a slow-motion crash that will take hundreds of millions of years. Don't worry, though. Stars are so far apart that most won't hit each other. It'll be more like 2 swarms of fireflies passing through one another, just with gravity doing parkour the entire time. And beyond that cozy cluster, there are about 2 trillion galaxies in the observable universe, arranged in enormous structures called superclusters and filaments. Picture the universe as a vast 3D web with galaxies strung along invisible threads of dark matter, forming shapes that resemble neurons in a brain too big for comprehension. Between those filaments, voids, massive stretches of almost nothing, where galaxies are as rare as polite Wi-Fi. Yet for all its grandeur, the universe plays favorites with the absurd. There are planets made of diamond, worlds where it rains molten glass sideways at thousands of miles per hour, and rogue planets drifting alone through interstellar space without a star, like moody cosmic drifters listening to sad playlists. There are quasars that shine brighter than entire galaxies, magnetars with magnetic fields so strong they could wipe your credit score from light years away, and stars so big they make the sun look like a flickering candle in a stadium. And through this swirling chaos, here you are, a cluster of atoms temporarily pretending to be a person, thinking thoughts about itself while floating on a rock that hurtles around a star that's spinning inside a galaxy, gliding through expanding space. You are a blink in time, a breath in the cosmos, and yet somehow aware enough to ask, what else is out there? Plenty. The universe hasn't even started getting weird. One of the strangest truths about the universe is that most of it has already slipped beyond our reach. Because space itself is expanding, galaxies farther than a certain distance are moving away from us faster than the speed of light, not by traveling through space, but because the fabric of space is stretching between us and them. Their light will never reach us. Entire galaxies are effectively vanishing over the cosmic horizon forever, like ships sailing beyond eyesight into an ocean with no shore. Every second, more of the universe becomes permanently unreachable. The view we have right now is the best it will ever be, like watching the last fireworks of existence fizzle into the dark. Then there's the cosmic microwave background, the ancient afterglow of the Big Bang. It's the oldest light we can detect, stretched and cooled over billions of years until it's just a faint whisper of radiation balanced a few degrees above absolute zero. Every time you tune an old TV to static, a tiny fraction of that fuzz is leftover light from the birth of everything. The first photons, still wandering after 13.8 billion years, bumping into your eyeballs through a screen built by sentient mammals made of star guts. If that doesn't make you feel both important and ridiculous, nothing will. Gravity, the quiet puppeteer of the cosmos, never takes a day off. It builds galaxies, births stars, guides planets, and occasionally crashes everything into everything else just to stay entertained. It's the weakest of the fundamental forces at small scales. You can jump, and for a moment you defeat the entire mass of the planet. But on the cosmic stage, gravity wins every time. It shapes the choreography of the stars, the orbits of planets, and the dance of galaxies gliding toward or away from one another across the darkness. And that darkness isn't empty. If you could scoop up a teaspoon of the vacuum of space, it would contain particles popping in and out of existence thanks to quantum mechanics, the most chaotic set of rules ever written into reality. In the quantum world, particles can be in multiple places at once, teleport across space, and borrow energy from nowhere as long as they return it quickly, like the universe is running on a cosmic honor system. The fact that your atoms are made of particles obeying these rules, yet you don't randomly disappear through your desk, is either a miracle or a bug the universe hasn't fixed yet. But let's talk scale, because if the universe had a hobby, it would be making you feel small. If Earth were the size of a grain of sand, the Sun would be the size of a door, and the nearest star, Proxima Centauri, would be another grain of sand 400 miles away. And that's just our tiny neighborhood. Light itself, the fastest thing allowed by physics, takes 8 minutes to travel from the Sun to Earth, 4 years to reach the nearest star, and over 100,000 years just to cross our galaxy. And yet, physicists think this galaxy is just one island among trillions, scattered through a cosmic ocean we've only just begun to chart. Some stars are so massive they burn through their fuel in a few million years, a blink compared to our Sun's cozy 10 billion year lifespan. Others, like red dwarfs, burn so slowly they could live for trillions of years. The universe will eventually go dark, but long after the Milky Way and everything in it has faded into memory, these tiny stars will still be burning like stubborn candles in a collapsing cathedral. The last star to exist may not ignite for another 100 trillion years, long after humanity is either evolved into something unrecognizable or dust scattered across the void. And the void itself, it's growing. Dark energy, whatever it is accelerating the expansion of the universe. Over time, galaxies that are visible now will slip beyond reach, their light stretched until it fades to black. Someday, far in the future, an intelligent species might look up at the night sky from some distant world and see no galaxies at all, just the dim remains of its own host stars. Their scientists might never know the cosmos was once filled with islands of light, but the universe is generous with its absurdity. Consider rogue planets, also called nomad planets, worlds not tied to any star, drifting alone through interstellar space. There could be hundreds of billions of them in our galaxy alone, wandering in the dark like cosmic hitchhikers. Some might have subsurface oceans kept warm by internal heat, potentially harboring life in caves beneath frozen crusts, organisms that will never see a sunrise. Then there are hot Jupiters, gas giants so close to their stars that their orbits take days or even hours. Their atmospheres boil and whip across their surfaces at thousands of miles per hour, leaving trails of vaporized elements in their wake. Some planets are tidally locked, with one side scorched at thousands of degrees, while the other remains in eternal darkness, frozen solid. Weather there isn't just dramatic, it's nightmare fuel wearing a tuxedo. Among the catalogue of gems out there is a planet called 55 Cancri E, believed to be made largely of carbon and compressed into diamond under immense pressure. Imagine a world twice the size of Earth, that's basically a jewel no one can steal because stepping onto its surface would vaporize you in half a second. The universe doesn't just flex, it flexes in diamonds. But even diamonds look boring next to black holes. We've talked about how they form, but what about what they do? They don't just sit there like cosmic drains. They warp space and time so intensely that anything that crosses the event horizon is never seen again. Some astronomers think black holes might connect to other parts of the universe or even other universes entirely, though no one's eager to jump in and check. And at their centers, a singularity, an infinitely dense, zero-volume point where physics taps out and says, "Ask someone else." And just when you think you understand the script, the universe drops a twist. There are supermassive black holes that shoot jets of energy and matter thousands of light years into space, bright enough to outshine entire galaxies. There are binary stars locked in orbits so tight they whip around each other in hours. There are stars that cannibalize their smaller companions like hungry cosmic piranhas. And above all of this chaos, the speed limit of the universe remains stubborn. Nothing can travel faster than light through space. But space itself? That's another story. Space can stretch, bend, and curve faster than light can travel through it. That's why distant galaxies can recede from us faster than light without breaking any rules, because the rules were written with loopholes big enough to drive galaxies through. And yet, somehow, in all this madness, you exist on a floating rock with breathable air, liquid water, and pizza. You are made of atoms forged in stars and held together by forces older than language, older than planets, older than light itself. You're not an observer of the universe. You are a piece of it looking back at itself with curiosity and caffeine. And the deeper you look, the stranger it gets. If you could step outside the universe and look at it from the outside, which for the record you can't, you wouldn't see planets or stars or galaxies first. You'd see motion. Everything is moving, drifting, colliding, stretching, collapsing, and exploding on timelines too vast for the human brain to store properly. Even the atoms in your body are mostly empty space, with electrons zipping around nuclei at speeds that would get a ticket in every galaxy. You're basically a ghost made of charged particles pretending to be solid. Zoom out, and the universe isn't just expanding, it's expanding faster the farther out you look. Imagine dots on a balloon. As you blow it up, each dot moves away from every other dot. There's no center, no edge, just stretching. That's your universe, except instead of air, it's powered by dark energy, that mysterious force accountants of physics still can't explain. They gave it a name so they could keep talking about it without screaming. Now consider this. The most common form of matter in the universe is hydrogen, the simplest atom. One proton, maybe a neutron if it's feeling ambitious, one electron if it's in the mood. Hydrogen is everywhere. It's the ink in which the universe first wrote its story. Every star begins by burning hydrogen into helium, and everything heavier than that has to be forged in the nuclear heartbeat of stars before being blown across galaxies like metal confetti. So if you wear gold, congratulations. You're accessorized with the remains of an exploding star that died billions of years before Earth existed. Some of those stars don't go quietly. Hypernovas, the even more dramatic cousins of supernovas, release more energy in a few seconds than the sun will emit in its entire lifetime. These cosmic meltdowns can produce gamma-ray bursts, beams so intense that if one hit Earth from thousands of light years away, it could strip away our atmosphere in seconds and erase life like someone deleting a file they didn't mean to create. And yet, life persists, not just on Earth, but likely elsewhere. With trillions of galaxies, billions of stars per galaxy, and probably more planets than grains of sand on all Earth's beaches combined, the idea that we're the only ones here feels less like science and more like ego. The odds of life existing somewhere else are so high they practically wave at you. The real question isn't, is there life out there? But, will we ever survive long enough to meet it without accidentally wiping ourselves out because Derek backed a satellite into the wrong button? But let's step back into the solar system, your messy cosmic neighborhood. Mercury is a scorched rock that gets so hot on one side and so cold on the other that it's basically a mood swing in planetary form. Venus is Earth's evil twin, the same size but wrapped in an atmosphere so thick and toxic it rains acid and crushes metal landers like soda cans. Mars is a dusty desert that used to have oceans, but now just has regret and robot tourists. Jupiter is a swirling storm of gas so massive it protects you by eating asteroids for breakfast. Saturn wears its rings like flashy jewelry made of ice and rock, while Uranus and Neptune quietly orbit in the outer cold, minding their business and being disrespected by memes. Then there's Earth, the improbable, ridiculous anomaly where complex life found a loophole and thrived. On a cosmic scale, everything about your existence is temporary and small, yet somehow your species invented mathematics, telescopes, nachos, and Wi-Fi and managed to fling robots out of the solar system. Voyager 1, one of those robots, is now drifting through interstellar space carrying a gold record with greetings, music, and images of Earth in case an alien species finds it and can both play vinyl and handle disappointment. But the wildest part? Everything you've seen, everything you've studied, everything telescopes capture is just the visible slice of the universe, the part whose light has had time to reach us. Beyond that, space could stretch on forever. Some scientists suspect the universe is infinite. Others think it might loop back on itself like a four-dimensional Pac-Man maze. There could be other universes entirely, each with different rules of physics, where time runs backward, gravity repels instead of attracts, or you're born with a tail and no one finds it weird. Even the atoms in your body aren't eternal citizens. Protons may eventually decay on timescales of 10 to the 34th power years. That's a number so large it might as well be a spell. By then, stars will have died, galaxies will have faded, and the universe will enter a stage called heat death, when everything is so spread out and energy is so diluted that nothing interesting can ever happen again. No stars, no planets, no movement, just endless darkness and particles drifting so far apart they might as well be alone forever. But before that final blackout, the universe has one last wild trick: Hawking radiation. Black holes, which you'd think would cling to their mass like dragons, might slowly evaporate over unimaginable spans of time, releasing energy as they shrink. A supermassive black hole could take 10 to the power of 100 years to disappear, a number so absurd it makes your birthday feel like yesterday. When the last one finally fizzles out, that may be the universe's final firework before everything goes quiet. And yet, despite all this philosophical demolition, here you are, alive in the one cosmic moment when stars still shine, water still flows, and consciousness can look up and ask, how did all this happen? You're living in the golden age of the universe without even realizing it. Future beings, if any exist, might spend their entire existence in darkness, piecing together what once was from the last whispers of ancient radiation. But right now, light still travels, galaxies still glitter, and space is still busy making stars like a factory that refuses to close. Comets still swing by like icy time capsules, asteroids still drift like forgotten bricks from the construction of planets, and somewhere out there, a system is being born where life might someday argue over taxes or invent noodles. And through all of it, you and every person you've ever known are walking collections of atoms with memories, dreams, fears, jokes, and the ability to name their pets after breakfast foods. The universe is incomprehensibly vast and ancient, but it's somehow made room for you to exist long enough to look around, ask questions, and occasionally Google pictures of baby sloths. And the story? It's still unfolding, whether you're watching or not. Somewhere in the dark, new stars are forming this very second. Giant clouds of dust and gas, nebulae, collapse under their own gravity until the pressure and temperature in their cores ignite nuclear fusion. They don't spark like campfires, they roar into existence with the fury of imprisoned atoms finally getting a chance to fuse and scream light into the void. These stellar nurseries are the wombs of the cosmos, birthing stars that will one day host planets, moons, storms, oceans, and maybe beings who think they're alone too. Some of these stars will live gentle, quiet lives and swell into red giants when they run out of fuel. Others will die in spectacular explosions that scatter elements across space in expanding waves of stardust. And some, the truly massive ones, will collapse into black holes so dense you could compress the Eiffel Tower into the size of a grain of sand and still have room for regret. And while all that is happening, galaxies are still on the move. The Milky Way itself is hurtling through space at over 1 million miles per hour, dragging the sun, the solar system, and your anxious thoughts along with it. You're spinning around Earth's axis at roughly 1,000 miles per hour, orbiting the sun at 67,000 miles per hour, and the entire solar system orbits the galactic center at 500,000 miles per hour, all while the galaxy itself is crashing through the cosmos like a bowling ball in slow motion. You're not standing still. You're surfing through space-time at speeds you'll never feel. And while you spin and fly and orbit through the cosmos, light is playing tag with time. Light leaving the sun takes just over 8 minutes to reach your eyes. Light from the nearest large galaxy, Andromeda, started traveling before humans existed, and the light from some distant galaxies we see in telescopes today set out before Earth itself had formed, back when the universe was just a toddler throwing matter around like alphabet blocks. It's not just distance that keeps secrets from you, it's time. Every time you look into the night sky, you're not seeing the stars as they are, but as they were. Some of them are already dead, their light still traveling toward you like a postcard from the past. Space is the best historian you'll never hire. Yet for all this grandeur, the universe is also wonderfully petty and chaotic. Planets get yeeted out of their solar systems during gravitational slap fights. Moons crash into their hosts or wander off to start a solo career. Asteroids sneak around like cosmic mosquitoes, occasionally taking out dinosaurs and ruining everyone's snacks. Stars steal matter from each other like jealous roommates. Galaxies collide in slow-motion cosmic mosh pits, sometimes merging peacefully, sometimes tearing each other apart in tidal chaos. And in the middle of it all, black holes lurk, not as vacuum cleaners gobbling everything in reach, but as silent tyrants of curvature. They don't chase matter, they simply bend space-time so aggressively that if you fall in, you're not so much swallowed as you are convinced there was never another option. Matter that spirals too close is shredded into streams of plasma and flung around the event horizon in blazing disks that glow brighter than anything else in the universe. And while those monsters roam space, the tiniest quantum particles dance to rules that barely make sense in any language. Entanglement allows two particles separated by light years to respond to each other instantly, like cosmic twins finishing each other's sentences before they're asked. Photons can behave like particles, waves, or both, depending on whether you're looking. There are virtual particles that appear and vanish too quickly to measure, but just long enough to nudge reality around like mischievous gremlins. Even time itself isn't as stable as you pretend it is. At the speed you're moving on Earth's surface, time for you ticks infinitesimally faster than it does for someone at sea level, because gravity and velocity stretch time like taffy. A clock on a satellite runs slightly faster than one on your nightstand, so GPS systems literally adjust for the fact that time is misbehaving. Without Einstein's equations, navigation would be so off course your maps would send you to the wrong continent. And the deeper you go into the unseen parts of the universe, the weirder it gets. Dark matter, the invisible glue of galaxies, doesn't interact with light or atoms. It just sits there, holding galaxies together through gravity, keeping stars from slingshotting into intergalactic retirement. If dark matter vanished, the Milky Way would fling itself apart like a CD in a microwave. Dark energy is even stranger. It's not just accelerating the expansion of the universe, it's doing it faster and faster, like the cosmos is stepping on the gas of existence with no plan for braking. No one knows what dark energy is. Some physicists suspect it might be a property of the vacuum itself, a kind of energy of nothing, which is exactly the sort of thing the universe would do to keep you awake at night. And if all that sounds overwhelming, remember, your brain runs on electricity generated by chemical reactions inside squishy tissue made of atoms that were once inside stars that exploded billions of years ago. The fact that stardust can worry about stardust is one of the funniest jokes the cosmos has ever written. But existence isn't done flexing yet. The largest structures in the universe are not galaxies, not clusters, but vast filaments stretching hundreds of millions of light years across, connecting everything like a web spun by a spider on cosmic caffeine. Between those filaments lie voids so empty they make outer space look crowded. Some of those voids are hundreds of millions of light years wide, with only a handful of lonely galaxies drifting through them like confused tourists in an abandoned mall. Even the shape of the universe is still up for debate. It might be flat and infinite, curved like a sphere, or saddle-shaped in ways that make Euclid spin in his grave. It could loop back on itself, so if you travelled far enough in one direction, you might eventually return from the other side, confused and itchy. And all the while, time itself may be flowing forward only because entropy, the universe's love of disorder, is rising like a slow tidal wave. You, meanwhile, are a temporary pattern stitched together by physics and chance, conscious for a blink, aware for a heartbeat, curious enough to ask how all of this works while sitting on a rock orbiting a star that is itself drifting around a galactic core it will never reach in its lifetime. And somehow, improbably, unbelievably, you're just getting started. Somewhere beyond the limits of what your telescopes can see, stars are dying in silence, galaxies are colliding in slow, majestic violence, and light from events that happened billions of years ago is still racing through space, destined to arrive long after your species has left the stage. The universe doesn't hurry. It doesn't pause. It doesn't ask permission to exist. It just keeps moving, reshaping itself, erasing its own history with every passing eon. Even the night sky you see isn't the one that exists. The stars above you are ghosts. Some burned out long ago, their light still travelling across the void like a message in a bottle that no one remembers sending. When you make a wish on a star, you might be whispering to the ashes of something that's already gone. Yet the light arrives anyway, loyal to a journey it didn't choose. And that light isn't just pretty, it's information. Astronomers decode the colours and wavelengths of starlight the way detectives study fingerprints. From a single beam of light, scientists can tell a star's age, composition, temperature, movement, and even if it's wobbling because of orbiting planets. You're living in an age where humans, bipedal animals with leftover survival instincts and questionable snack choices, can detect exoplanets by the way they make a star wiggle. Some of those planets are so close to their stars they complete an orbit in hours. Others orbit so far away they take centuries or millennia to loop around once. There are planets with double sunsets because they orbit two stars, and planets that orbit dead stars, lit only by memories. There are super-Earths, mini-Neptunes, ocean worlds, and ice giants covered in storms colder than liquid nitrogen. The universe doesn't do standard model of planets any more than it does simple. Take TRES 4b, for example. It's bigger than Jupiter, but so puffy it's less dense than cork. You could throw it into a space ocean and it would float like a drunken inflatable pool toy. Then there's HD 189733b, a planet where it rains molten glass sideways at 4,000 miles per hour. Earth has hurricanes. This thing has death glitter storms. Or consider Jupiter's moon Io, the most volcanically active object in the solar system. It's constantly erupting, spewing sulfur and molten rock into space like it's auditioning for a metal album cover. Then you have Europa and Enceladus, moons with icy crusts and oceans of liquid water beneath. They have geysers that shoot water vapor into space, and beneath that ice, conditions where life might be hiding in the dark, plotting to surprise you. Even comets, the cosmic leftovers of the solar system's construction, carry secrets. They're frozen time capsules from the dawn of the planets, filled with water, carbon, and the ingredients for life. They crash into worlds, deliver materials, and sometimes cause extinctions. They don't care if you're impressed. They've been here longer than your continents. But while you marvel at planets and moons, the universe is busy sculpting structures too large for your imagination to grip. Galaxy clusters bound together by dark matter-form walls and filaments that stretch across hundreds of millions of light-years. They look like cosmic spider webs, nodes of light connected across formidable emptiness. And in the spaces between, voids so empty that if the Milky Way sat inside one, you wouldn't see another galaxy in the sky at all. It would be a darkness so pure it would feel like silence made visible. And yet, against all odds, life emerged on at least one world. On Earth, chemistry became biology, biology became curiosity, and curiosity started naming constellations and asking questions about the stars that burned before its atoms were ever assembled. Stars forged the elements that became your bones, and now those same bones are trying to understand the stars. It's cosmic recycling with style. But your place in this universe isn't permanent. In about 5 billion years, the sun will swell into a red giant, growing so large it might swallow Mercury and Venus and turn Earth into a roasted husk. Long before that, the oceans will evaporate, the atmosphere will boil off, and this planet will become uninhabitable. You're living in a temporary pocket of comfort between chaos and more chaos. And after the sun dies, it will shed its outer layers in a glowing cloud called a planetary nebula, leaving behind a white dwarf, a hot ember of a star, about the size of Earth but with half the sun's mass. It will glow gently for trillions of years before fading into a black dwarf, cold and silent. No fireworks, no applause, just the quiet end of a long, bright life. But don't worry, the universe has bigger plans. Long after the sun is gone, galaxies will merge, black holes will feed, stars will be born and die, and space will keep stretching until distant galaxies vanish from view one by one. Eventually, only the local group of galaxies will remain visible, and then those too will merge into a single swollen galaxy, drifting in the dark. Far beyond that time, stars will stop forming altogether. The last red dwarfs will burn their final hydrogen and flicker out. Only black holes, neutron stars, rogue planets, and cold remnants will remain. And then, over unimaginable timescales, even black holes will evaporate into nothing. What remains will be a thin smear of particles in a universe approaching absolute zero, a silent, lightless expanse where nothing new happens and nothing old survives. But that's the far future. Right now, stars still shine, galaxies still spin, Space is still buzzing with radiation and particles and wandering worlds that haven't yet found their headlines. Right now, existence is loud and bright and weird and full of potential. And you, improbably, exist in the one sliver of cosmic time where the universe is both knowable and active. You live in the flame between darkness and darkness, and somehow you're capable of understanding that you are made of atoms older than Earth, breathing air exhaled by ancient trees, thinking thoughts powered by the remains of dead stars. And while your life might feel tangled in bills, noise, and everyday survival, the atoms that make up your brain once helped fuel suns, once drifted through stellar winds, once cracked and fused and scattered across space before settling into a planet that didn't exist until recently in cosmic terms. You are not small. You are vast in origin and temporary in assembly. And the universe hasn't even shown you all its tricks yet. Even the things you think of as permanent are temporary flickers in a universe that doesn't do permanence. Mountains rise and erode, oceans form and vanish, continents drift like lazy rafts on molten stone. Civilizations appear, make noise, build towers, argue, collapse, and leave behind bones and pottery for future beings to misinterpret. But the atoms themselves, the stardust you're made of, have been circulating through stars, planets, comets, and organisms for billions of years and will continue long after your name fades from memory. The iron in your blood was forged in the heart of a massive star that exploded before the sun even existed. The oxygen you breathe was exhaled by ancient algae that lived in oceans when the continents were unrecognizable. The calcium in your bones was once trapped in the corpse of a star that died in fire. You are not a separate observer of the universe. You are the universe, briefly organized into a pattern capable of noticing itself. And yet, the universe holds more secrets than answers. There are entire categories of phenomena you don't even have proper language for. Dark energy drives expansion. Dark matter binds galaxies. But then there are concepts even stranger. Phantom energy, cosmic strings, brain worlds, multiverses, dimensions beyond your perception. There might be infinite variations of existence stacked like sheets of paper, touching but never interacting. There could be versions of you in other realities that made different choices, wearing different socks, wondering the same unanswerable things. The cosmic inflation that blasted the universe into size may have created bubble universes, each with different physical constants, rules, and fates. Some may have collapsed instantly, others may be filled with matter made of particles that don't exist in your universe. You might be living in just one cosmic bubble floating in an infinite froth of realities, and you'll never meet your neighbors because the laws of physics declared a restraining order. And even if this is the only universe, you've still seen nothing. The observable universe, the part whose light has reached you, is just a bubble with a radius of about 46 billion light years. But beyond that horizon, the cosmos continues. Some estimates suggest the universe could be hundreds of times larger than what you can see, or infinite, or looping, or finite but unbounded, like the surface of a sphere, except in dimensions your brain refuses to install. But let's return to the visible universe, because even that contains more wonders than your lifetime can cover. Consider quasars, the bright, screaming hearts of young galaxies, where supermassive black holes are devouring matter so violently that the energy emitted can outshine all the stars in the galaxy combined. Light from some quasars began its journey over 12 billion years ago, before Earth was even an idea. You are seeing the tantrums of baby galaxies that have already grown old or faded. Or pulsars, the corpses of massive stars that spin faster than blender blades and emit beams of radiation with the precision of a cosmic lighthouse. Some rotate hundreds of times per second, powered by the leftover angular momentum of a collapsed core so dense it would crush a mountain into a sugar cube. They're like the universe's most aggressive metronomes, ticking in radio waves across light years. Magnetars take it further. These are neutron stars with magnetic fields so powerful they could tear apart atoms from a distance. If you brought a magnetar as close as the moon, it would wipe the data off every device on Earth and rip metal apart at the molecular level. Thankfully, they keep their distance, sulking in silence light years away. And between all these celestial beasts, the void stretches on, a vacuum not truly empty, but filled with particles blinking in and out of existence, radiation drifting like forgotten whispers, and lonely photons traveling for billions of years with no guarantee they'll ever hit anything. The silence out there is not peaceful, it's ancient. But the quiet doesn't erase the chaos. Entire stars get swallowed by black holes every few days somewhere in the universe. Galaxies cannibalize their smaller companions. Stars get slingshotted into intergalactic space at millions of miles per hour. Planets collide and merge or get ripped away from their systems during close passes. And somewhere, a supernova just went off with the force of 1 trillion nuclear bombs, scattering elements that will one day form new clouds, new stars, new worlds. And then, improbably, things like daisies, dolphins, violins and laughter appear on one tiny rock, orbiting an average star in a nondescript galaxy tucked away in a cosmic suburb. You are living in a sliver of time where consciousness can exist, between the early violence of starbirth and the slow fading of cosmic exhaustion. But don't mistake rarity for fragility. The universe doesn't care that life is improbable, it just runs probabilities at scales so large that the unlikely becomes inevitable. You are the result of physics played out over billions of years through nuclear fusion, gravity, chemistry, and evolution. You are a byproduct of stars exploding with enough enthusiasm to scatter ingredients across light years until some of those ingredients learn to ask, "What the hell is going on?" And despite all the vastness beyond you, your existence is as much a part of the universe as the galaxies you point telescopes at. The laws that govern quasars govern neurons. The particles in your heart were born in furnaces that lit the early universe. The photons leaving distant galaxies are relatives of the photons that let you read these words. Reality doesn't separate you from the cosmos. You are stitched into it, atom by atom, moment by moment. You aren't in the universe. You are the universe, briefly arranged in a form that can think, feel, panic, love, laugh, and wonder before returning to the stars that built you. And somewhere out there, light from a star that hasn't even died yet is already on its way to meet you. Think about this. The universe is constantly broadcasting, not in radio shows or podcasts, but in light, radiation, and gravity. Every star beams, every black hole whispers through ripples in space-time. Every galaxy radiates signals across the spectrum. The problem is, most of it isn't tuned for human ears or eyes. The cosmos is a cacophony, but you only hear a faint hum. If your senses could pick up the entire electromagnetic spectrum, the night sky wouldn't be a quiet black canvas sprinkled with dots. It would be a riot of color and energy, with waves of radio light washing through, ultraviolet flares bursting like fireworks, X-rays sizzling from collapsed stars, and microwave static coating everything like a universal background music track. And even without tuning in fully, you're already bathing in cosmic rays. These high-energy particles zip through your body constantly, so small you don't notice, so fast you can't dodge them. They slam into Earth's atmosphere, creating showers of secondary particles that occasionally streak down into your DNA. Most do no harm, but over billions of years, they've been writing in the margins of biology, introducing mutations that shaped evolution. Life as you know it isn't just the product of Earth. It's been sculpted by space itself. The strangest part is how much of this you'll never see. Light from distant galaxies is stretched into longer, redder wavelengths as the universe expands, a phenomenon called redshift. Some galaxies are shifted so far into the infrared that they're invisible to your eyes. Telescopes like Hubble and James Webb can catch them, but what they're really doing is peering back in time to see galaxies as they were when the universe was still learning how to grow. When you look at those pictures of faint, smeared galaxies billions of light years away, you're not seeing what they are. You're seeing what they were before Earth even existed. You're looking at ancient photographs of the universe, still developing in a cosmic darkroom. And this time machine effect goes both ways. If there's someone looking at Earth from 65 million light years away, they wouldn't see cities, oceans, or the internet. They'd see dinosaurs still walking across continents, unaware of the asteroid with their name on it. If they're a billion light years away, they might see Earth as nothing but a glowing newborn, molten and angry, before life found its foothold. To see Earth as it is now, they'd have to wait millions of years for the light carrying your present to reach them. Every view of the sky is a lie told by distance and time. But the universe is generous with illusions. Light bends around massive objects, creating gravitational lenses that magnify distant galaxies like warped glass. A single cluster of galaxies can bend the light of galaxies behind it into arcs and rings, tricking you into seeing the same object multiple times. It's as if the universe built its own funhouse mirrors, showing you distorted echoes of the past through the curvature of space-time itself. And scientists use those distortions to map dark matter, the invisible scaffolding holding everything together. You can't see it directly, but you can watch how it pulls light off its path, like footprints left by something too heavy to notice. Then there are the gravitational waves, ripples in space-time itself, first predicted by Einstein and confirmed a century later when detectors caught the faint shiver of two black holes colliding a billion years ago. Imagine two invisible monsters spiraling into each other, colliding with so much force they sent tremors across the fabric of the universe, and billions of years later, sensitive instruments on Earth shook ever so slightly in response. For the first time, humans didn't just see the universe. They felt it move. And while you marvel at galaxies, stars and black holes, don't forget the smallest actors, particles that mock your understanding of matter. Neutrinos, for example, stream through you by the trillions every second. They come from the sun, from exploding stars, from nuclear reactions, passing through your body and the entire planet as if matter doesn't exist. They barely interact at all, ghostly travelers that remind you just how little of the universe you can grasp. Physicists build enormous detectors filled with ultra-pure water or ice just to catch the rare occasion when one of these ghosts bumps into an atom and leaves behind a faint flash of light. Zoom back out and you see the scale again. The largest stars, called hypergiants, are so enormous they could swallow Earth's orbit and still have room for dessert. The smallest stars, like red dwarfs, glow faintly, barely keeping themselves alive, but they make up the majority of stars in the universe. And between them is a whole zoo of exotic stellar creatures: white dwarfs, neutron stars, pulsars, magnetars, each stranger and more extreme than the last. Some spin faster than a kitchen blender. Some could erase a city just by wandering a little too close. And some are just quietly fading into nothing. A reminder that even stars have expiration dates. But it's not just stars and galaxies that push the limits. The universe itself seems to enjoy paradoxes. Time, for example, is tied to entropy, the tendency of systems to move from order to disorder. That's why you remember yesterday but not tomorrow, why coffee cools instead of heating itself up spontaneously, why the universe marches forward instead of rewinding. Yet at the deepest levels of physics, the laws of nature don't actually care which way time runs. Equations work just as well backward as forward. Time's arrow is less a law and more a suggestion, enforced by probability and the fact that chaos is easier to make than order. And then there's the possibility of the multiverse, the idea that our universe is just one bubble in an endless cosmic foam. Maybe there are infinite universes, each with its own laws, constants, and outcomes. Some might be lifeless expanses of eternal fire or ice. Others might look almost identical to ours, with tiny differences, a different history, a different you. If this is true, your existence isn't a miracle. It's inevitable, one of countless variations across endless realities. You're just tuned into this one for now. Yet for all the uncertainty, all the unknowables, all the distances so vast they fold your sense of meaning inside out, you're here, right here. A living pocket of the universe capable of wonder. You are built from particles that have traveled across space and time, forged in stars, scattered by explosions, gathered into planets, and shaped by billions of years of improbable accidents. You don't need to look far for the universe. It's already inside you, buzzing, humming, and keeping you alive. And as you drift through the void on your spinning rock, remember, the universe isn't a cold, indifferent place. It's a stage, and everything from galaxies to microbes to you are players in its story. Your heartbeat is as much a cosmic rhythm as the orbits of planets. Your thoughts are as much a phenomenon as the fusion at the heart of the sun. You're not separate from the cosmos. You are the cosmos, briefly awake, staring back at itself in awe. Somewhere far beyond the reach of your eyes or instruments, clusters of galaxies are tearing away from you faster than light can chase them, not because they're speeding through space, but because space itself is expanding beneath them like a conveyor belt with no off switch. Those galaxies are already gone from your future, their light destined never to arrive. Entire realms of stars, planets, black holes, and unimagined wonders are slipping past the cosmic horizon every moment, erased from the observable universe, not by destruction, but by distance. And even closer to home, the universe hides things not because they are far, but because they are quiet. Brown dwarfs, the failed stars too small to ignite fusion properly, drift in darkness between solar systems. They glow faintly in infrared but remain invisible to your eyes. They aren't planets, but they aren't stars either. Cosmic almosts, sitting in the grey zone of existence. Some may host moons, and those moons might have subsurface oceans warmed by tidal flexing or radioactive decay. Life could be hiding right now in the pitch-black waters of a moon orbiting a star that never truly lit. Black dwarfs, the hypothetical corpses of white dwarfs, don't exist yet, but will one day. It will take trillions of years for white dwarfs to cool to absolute darkness, and none have had enough time to do so. They are the future's ruins, relics of stars long gone cold, waiting for a universe old enough to forget light. Then there are the rogue planets wandering starless through the dark, no sunrise, no orbit, no warmth except for whatever heat they still carry inside. Some might be wrapped in thick atmospheres that trap that heat, creating alien oceans beneath ice or clouds. A world like that could drift for billions of years, never seeing a star, yet still carrying seas and storms no one will ever witness. But existence doesn't reserve its strangeness for dead stars and lonely planets. There are galaxies so massive they warp the light of more distant galaxies into rings and arcs. There are galaxies with no stars at all, made mostly of dark matter and gas that never ignited. There are ring galaxies, lenticular galaxies, irregular galaxies that look like smeared ink, and ultra-diffuse galaxies so faint that you could pass through one and never know it. And then There are galactic collisions. When galaxies crash, it isn't like two cars smashing metal. It's more like fog banks passing through each other while the stars within them dance gravitational ballet. Some stars get flung into intergalactic space like sparks from a grinder. Others settle into new homes as the galaxies merge into one, reshaping themselves over millions of years into spirals or ellipticals or some new structure entirely. And in the chaos, gas clouds collide and compress, igniting new generations of stars. Destruction feeding creation, again and again. On the smallest scales, the universe does the opposite. It refuses to give you clear edges. Atoms are mostly empty space. Electrons don't orbit like planets around a sun. They blur into probability clouds, smeared out across regions of space they may or may not occupy. Particles pop into existence and vanish without warning, as if the vacuum itself is whispering half-finished thoughts. The deeper you look, the more matter dissolves into math. And yet, all of it scales up into everything you know. Stars form because gravity overcomes pressure. Planets form because dust sticks together, then snowballs into rocks, then boulders, then worlds. Moons form from crashes or captures or leftover debris. Life forms because chemistry refuses to stay inert when energy and time conspire together. Consciousness forms because matter, under the right conditions, learns to reflect on itself. But every miracle in existence is temporary. The earth you stand on is not permanent. Its continents will drift into new shapes, its oceans will shift, its core will cool, and one day its sky will be red and swollen as the dying sun expands. The orbit of the moon increases by about 1.5 inches every year as tidal forces push it away. Eventually, it will drift too far to cause strong tides, and Earth's rotation will slow until one day is as long as a month once was. Everything changes, even things that seem immortal. And beyond Earth's eventual fate lies the far stranger journey of the Sun. When it exhausts the hydrogen in its core, fusion will falter, and the core will contract under its own gravity. The outer layers will swell, and the Sun will become a red giant so large it may engulf Mercury and Venus, or more. Earth will be scorched into a lifeless rock or vaporized entirely. After that, helium fusion will blaze briefly before failing too, and the Sun will shed its outer layers into a glowing cloud of gas, a planetary nebula. What remains will be a white dwarf, a dense ember the size of Earth, cooling slowly, shining with leftover heat. It will not burn fuel. It will simply fade for trillions of years until it becomes a cold black dwarf, invisible against the dark. But even that long twilight is young compared to the universe's future. Long after the last stars die, long after galaxies fade, long after black holes evaporate, matter itself may decay, leaving behind only radiation and subatomic particles drifting in the silence. Protons might break down into lighter particles over timescales too vast to write clearly. Eventually, the universe may reach maximum entropy, a state where no energy gradients remain to drive anything, no stars, no movement, no structure, just an endless frigid expanse where nothing new happens and nothing old remains. And yet, despite that eventual quiet, the present is a riot of energy and form. Stars still ignite, nebulae still glow, planets still dance in orbits shaped by collisions and gravity. Life still experiments with shapes, behaviors, and instincts. The cosmos still sings in radiation, still rumbles in gravity waves, still paints the darkness with light. And in the middle of all that motion and silence, you get to exist. You, a creature made of ancient atoms and fleeting thoughts, living in the single era when the universe is luminous, structured, and observable. You're here at the rare cosmic moment when stars still burn, Galaxies still shine, and the past is still glowing across billions of light years to reach your eyes. You are not late to the universe. You are not early. You are exactly on time for the show that only happens once. Even though everything changes, the universe has a way of making the temporary feel eternal. Stars might live for billions of years, but they still burn through their fuel like they're racing toward an invisible finish line. Some die quietly, shrinking into white dwarfs that glow like fading embers. Others die so chaotically they rip themselves apart and scatter their remains across light years, seeding the galaxy with elements that will one day assemble into new suns, planets, and maybe another thinking creature wondering where it came from. Gravity is the secret archivist of the cosmos, gathering lost material and recycling it into new forms. Nebulae, vast clouds of gas and dust, might look calm in pictures, but inside them stars are forming from the wreckage of old ones. It's a quiet kind of reincarnation, except instead of souls, it's protons and electrons returning to the furnace. Some of those clouds stretch across dozens of light years, filled with cold hydrogen waiting to be called into structure. If you could float through one, you wouldn't hear anything, because sound can't move through such thin material, but you'd be surrounded by the ashes of ancient stars and the seeds of new ones. And space isn't as empty as it looks. Even in the coldest void, there are particles drifting, photons gliding, and virtual particles blinking in and out of existence so fast you'd miss them even if you could see that small. Space is more ocean than emptiness, and every so often something crosses your path. An asteroid, a comet, or a cosmic ray that's traveled millions of years just to smack into your atmosphere and explode into a shower of subatomic confetti. Your planet has been hit more times than it remembers. Asteroids and comets have shaped the landscape, wiped out species, and delivered water and complex molecules from space. Earth wasn't born with oceans. They arrived by delivery service, dropped off by icy bodies flung inward from the outer solar system. Life might owe its origin to a rock that showed up uninvited. But while Earth is old, it's not ancient compared to the universe. For most of cosmic history, Earth didn't exist. For most of Earth's history, life was microscopic. And for most of human history, the stars had no names, and no one knew they were other suns. Even now, your species has seen only a fraction of its own solar system up close and visited only one world besides its own. You've sent probes to the outer planets, but they're still just beginning their journey, sailing farther into the dark with golden records and fading signals. Beyond them, the Kuiper Belt and Oort cloud hold the leftovers of planetary construction. Icy bodies drifting in deep freeze, some waiting for a gravitational nudge to fall inward as comets. And beyond that, interstellar space stretches in every direction, filled with dust, particles and radiation, but almost no atoms compared to what you breathe. If you stood in the middle of that space, ignoring the fact that you'd die instantly, you would see nothing, hear nothing, feel nothing, and yet you'd still be surrounded by distant stars whose light started traveling before your planet formed. And somewhere beyond those stars, things are happening that you'll never witness. A black hole is consuming a star and spitting radiation into space like a cosmic blowtorch. A gas giant is getting torn apart by tidal forces because it strayed too close to its sun. A planet is forming around a young star, its surface molten, its sky a haze of steam and dust. And somewhere else, two neutron stars are spiraling toward each other, getting closer with each orbit until they collide in a burst of energy that for a moment outshines 1,000 galaxies. Those collisions forge heavy elements, gold, platinum, uranium, metals that later fold into planets, asteroids, and eventually jewelry, circuitry, and radioactive medicine. Every ring, chain, and coin made of those elements is a souvenir from a collision so violent it rippled space-time. Even the cosmic background radiation, the faint afterglow of the Big Bang, still hums through everything. It's everywhere you go, a temperature just a few degrees above absolute zero, the universe's baby picture painted across the sky in microwaves. It's not loud or flashy, but it's ancient, older than the oldest star, a relic of a time when everything was too hot and dense for light to travel freely. And yet, everything you see now came from that. The universe started so uniform that everything looked the same in every direction, but tiny fluctuations, little wrinkles in density, grew over time into galaxies, clusters, and superclusters. Without those tiny imperfections, there would be no stars, no planets, no life. The universe didn't need perfection to create you, it needed wrinkles, and it's still shaping itself. Galaxy clusters are still merging, stars are still being born, dust from old explosions still drifts across light years before being pulled into new forms. Somewhere out there, a world is cooling for the first time, its crust hardening over an ocean of magma, its atmosphere still toxic and steaming. Somewhere else, a world is dying, its seas boiling, its air thinning, its last organisms fading into the soil. Even the speed of light is not the speed of information across the cosmos. It's just the limit of what you can see. Everything past the cosmic horizon is hidden by time itself. The light from those regions will never reach you, because space expands faster than light can cross it. The observable universe isn't everything. It's just the part of the story that's arrived so far. But even confined to this bubble of visibility, you're surrounded by trillions of stars and uncounted worlds. Some are young and violent, some are old and quiet, some are gone, but still shining in the past you can see. And between them lie the mysteries that no telescope or theory has solved. The nature of dark matter, the fate of dark energy, the laws that govern the earliest moments of existence. The universe keeps no archives you can access, but it leaves clues everywhere, written in light, gravity, and the structure of space itself. Every galaxy's spin, every wobble of a star, every ripple in the cosmic microwave background is a signature from an earlier era. You're piecing together a story told across billions of years by things that no longer exist. And somehow, that story includes you, a being made of atoms that remember what it was like to burn in stars and freeze in the void, now arranged in a form that can think, question, imagine, and choose. And the universe, it isn't done speaking. Even though you can't see most of the universe, it's still acting on you every moment. The gravity from distant galaxies, though faint, still tugs on you. The radiation from ancient stars passes through your body. The space around you is curved ever so slightly by everything that exists, and you're moving along those curves without noticing. You're not standing on solid ground. You're gliding on a fabric of space-time that bends and flexes beneath and around you, shaped by everything with mass and energy. Einstein didn't just rewrite the rules of gravity, he exposed how limited your senses are. You feel weight, but you don't feel space-time bending around you. You move through time, but you don't notice that time flows differently depending on where you are and how fast you're going. A clock at the top of a mountain ticks faster than one at sea level. Astronauts on the International Space Station age slightly slower than people on Earth's surface because of both speed and altitude. You're living in a universe where time is a suggestion, not a guarantee. Even the vacuum of space isn't truly empty. It's filled with quantum fluctuations, fields, and virtual particles blinking into and out of existence in moments so brief they defy language. Every square centimeter of empty space contains more potential energy than all the stars in the observable universe combined. You just can't access it. Existence is extravagant, even where it pretends to be quiet. But space doesn't just bend. It vibrates. When massive objects like black holes collide, they send out ripples in space-time, gravitational waves that stretch and squeeze everything in their path. These ripples move at the speed of light, passing through planets, people, and atoms without resistance. Detectors on Earth have recorded these shivers, triggered by cataclysms that happened billions of years ago. Long before humans learned to make fire, two black holes collided and sent out a signal that would one day whisper through a laser beam and prove Einstein right again. Meanwhile, stars don't just shine quietly, they pulse, flicker, flare, and sometimes devour their own planets. Some stars spin so fast they flatten at the equator. Others emit bursts of energy that could sterilize a world from light years away. There are variable stars that brighten and dim in precise rhythms, like cosmic heartbeats, and Cepheid variables that helped humanity measure the size of the universe long before anyone knew what dark energy was. And then there are supergiants like Betelgeuse, a swollen red star nearing the end of its life. One day it will explode in a supernova visible from Earth even during the day. It might happen tomorrow or in 100,000 years, but the light from that explosion will take centuries to reach you. The star may have already died, and you're just waiting for the universe to deliver the message. Massive stars don't just explode. They leave behind corpses so dense they warp reality. Neutron stars are made of matter crushed so tightly that a teaspoon of it would outweigh a mountain. Black holes take it further, folding mass into a point with no spatial dimensions at all. And yet, they're surrounded by disks of gas so hot they glow with X-rays. And sometimes they fire jets of energy thousands of light years long, piercing the dark like cosmic spears. Even planets aren't as simple as they seem. Some have molten cores that generate magnetic fields, protecting their atmospheres from solar winds. Others lost that protection and had their air stripped away, becoming deserts or frozen wastelands. Some planets are tidally locked, with one side in eternal day and the other in endless night. Some have seasons that last centuries. Some have winds faster than bullets. And moons. Moons are worlds in disguise. Titan has lakes of liquid methane and an atmosphere thicker than Earth's. Europa hides an ocean beneath its ice crust that might hold more water than all of Earth's seas combined. Triton orbits Neptune backward, a captured object from the Kuiper Belt, frozen and geologically active at the same time. Even your moon is slowly drifting away, changing tides and days so gradually you won't notice until it's gone. And while planets and moons spin and drift, cosmic debris races along hidden highways. The Oort cloud, a distant shell of icy bodies, stretches nearly a light year from the sun. It's a graveyard and a nursery, sending comets inward when gravity nudges them. Some will break apart. Some will crash into worlds. Some will slingshot back into darkness for another million-year orbit. Even closer, the asteroid belt isn't a shattered planet. It's a failed one. Jupiter's gravity prevented it from forming, and now those rocks just drift, collide, or sometimes fall into the inner solar system as meteorites. The iron in your blood may have come from one such collision long before humanity existed. Yet, for all its violence, the universe makes room for delicate balance. Earth just happens to sit in the habitable zone of a stable star, with a moon that stabilizes its tilt, a magnetic field that shields it from harmful radiation, and just enough greenhouse gases to maintain oceans without boiling or freezing them. You live in a cosmic sweet spot, one that won't last forever but is more than long enough to matter. And even in this perfect accident, you're still at the mercy of the cosmos. A gamma ray burst from a nearby star could end complex life in seconds. A rogue planet could wander in and disrupt Earth's orbit. A large enough solar flare could fry the electrical infrastructure your world relies on. The solar system is calm only because nothing has disturbed it lately. Yet here you are, thinking, building, dreaming, and looking out into the dark with curiosity instead of fear. You map the stars, decode their light, send machines to other worlds, and listen for signals in the static. You are a species that evolved on a grain of dust and now studies the birth of galaxies. You're made of particles that once burned inside stars and now form questions the universe is answering one clue at a time. And somewhere, light from a galaxy that died before Earth existed is on its way to you, carrying a message you won't understand but will still try to read. Every photon traveling through space is a story in motion. Some began their journey inside the core of a star, bouncing around for thousands of years before escaping into the void. Others were born in the first seconds after the Big Bang and have been stretching with the universe ever since, their wavelengths pulled longer and colder by expansion. Some photons will travel forever and never hit anything. Others will end their journey in the back of your eye or the lens of a telescope, or the atmosphere of a world no one has named. The universe doesn't waste paths. Light, particles, and gravity weave through space-time like threads in a tapestry too large to see from the inside. Even the darkness between galaxies vibrates with possibility. Particles that don't interact with light, like dark matter, still shape the cosmos with invisible hands. Without it, galaxies wouldn't hold their stars. They'd spin too fast, fling themselves apart, and dissolve into emptiness. Dark matter acts like scaffolding, and even though you can't see it, every galaxy is wrapped in a massive halo of the stuff, extending far beyond the stars you can detect. And while dark matter holds things together, dark energy pushes everything apart. It's not a force you can see or measure directly, but its fingerprints are everywhere. The expansion of the universe isn't slowing down like everyone once assumed. It's speeding up. Every distant galaxy you see is racing away from you, not because you're at the center, but because every point in space is stretching. The farther something is, the faster it recedes. Eventually, galaxies beyond a certain distance will disappear from view forever, leaving only a shrinking island of visible stars in a darkness that was once crowded. But the universe doesn't erase without replacing. New stars still spark in cold nebulae, and old stars collapse into remnants that defy imagination. Some leave behind white dwarfs, slowly cooling over trillions of years. Some collapse into neutron stars, so dense their cores are packed with matter in forms you don't fully understand. Possibly a sea of neutrons, possibly quark matter, possibly something no one has imagined yet. And some stars go beyond collapse, punching through the limits of understanding and becoming black holes, regions where gravity becomes so strong that the concept of outside stops making sense. Black holes aren't holes in the classic sense. They're places where matter has been crushed past the point of form, where space itself is curved so severely that all directions lead inward. If you fell in, you wouldn't fall through something. You'd fall into inevitability. You wouldn't see it coming either, because from your perspective, nothing special happens when you cross the event horizon. But to an outside observer, you'd appear frozen in time, stretched, dimmed, and eventually faded into the background as your signal redshifted into oblivion. Yet black holes aren't silent. They warp light and gravity and time around them, and when they consume matter, they can create jets and disks so bright they outshine galaxies. Some black holes sit quietly for eons, others gorge on entire stars, and some drift through interstellar space without a trace, invisible unless they bend the light of something behind them. There are probably black holes roaming the Milky Way that no one has seen, dark giants sailing through the cosmic sea like sharks under moonless water, and even these monsters don't last forever. According to Hawking's theory, black holes slowly evaporate, losing mass as they emit tiny particles near their event horizons. For stellar-sized black holes, this process takes longer than the current age of the universe by such a ridiculous factor that numbers lose meaning. For the biggest black holes, the timescale is even more absurd. They may be the last things to exist before everything becomes radiation and emptiness. But before all that silence arrives, the cosmos carries on with its theatre. Stars orbit each other in binary systems, locked in gravitational embrace. Some feed on their companions, pulling gas away like cosmic parasites. Others explode as Type 1a supernovas when they reach the critical mass needed to detonate. These explosions don't just light up the universe, they serve as cosmic mile markers, helping astronomers measure distances across billions of light years. And then there are the quiet stars, the red dwarfs that barely burn their fuel and will outlive everything else by trillions of years. They don't shine brightly, but they endure. If the universe were a long novel, red dwarfs would be the characters still standing in the last chapter, watching the universe grow cold. Planets around those dim stars might still exist when the Milky Way and Andromeda have merged into one giant elliptical galaxy and the night sky is completely different. Life, if it survives that long, might evolve beneath faint red suns, in worlds warmer on the inside than the surface. Or maybe it will drift through space, spreading from one world to another across millions of years, not in ships of metal, but in frozen microbes hitching rides on rocks. The farther you look, the more the universe refuses simplicity. There are stars older than the planets you walk on. There are planets that formed before Earth existed, still orbiting suns you can't see. There are galaxies that collided before your solar system was a cloud of dust. And in every direction, time stretches backward in layers, like sediment in a cosmic canyon you're trying to read in reverse. Yet somehow, in all this vastness, your species has learned to measure the speed of light, detect planets orbiting distant suns, and listen for signals across the galaxy. You've sent machines to the edges of the solar system, landed probes on comets, and photographed black holes by linking telescopes across the globe. You are a temporary arrangement of matter studying matter, a momentary consciousness deciphering a story billions of years old. And the universe continues whether you look or not. Stars will form, planets will collide, moons will crack, light will travel, gravity will pull, space will stretch, and somewhere in the folds of a galaxy you'll never see, something extraordinary will happen with no witness but time itself. But for this moment, in this blink of cosmic history, you get to be aware of it. You get to exist in the age of light, in the era when the night sky is full, when galaxies still glow, when stars still burn, and when questions can still be asked before the answers fade with everything else. And while the universe is vast beyond comprehension, you're woven into its fabric, made of its dust, powered by its physics, and destined to return to it in pieces. You don't stand outside looking in. You are the inside, awake for a moment in the dark. The night sky you see now is temporary, a snapshot in a universe that never stops rearranging itself. Constellations you recognize today are accidents of perspective, stars that only appear close because of your angle on space. Given enough time, they'll drift apart, shifting into new shapes generations of humans will never see. Some of the stars you look at are already dead, their light still crossing the gulf long after their cores collapsed or exploded. You don't see the universe as it is, you see it as it was, scattered across a timeline of light. Galaxies themselves aren't fixed either. The Milky Way is on a collision course with Andromeda, barreling toward it at about 110 kilometers per second. There won't be an explosion when they meet. Instead, they'll pass through each other in slow motion, stretching, merging, and reshaping over a few billion years. Stars will fly into new orbits, gas clouds will compress into star-forming regions, and the two galaxies will eventually become one. An enormous elliptical system that may shine for trillions of years after all the spiral galaxies fade. But collisions aren't the only form of cosmic motion. Everything orbits something. The Earth orbits the Sun. The Sun orbits the center of the Milky Way. The Milky Way orbits within a cluster of galaxies. Those clusters drift through superclusters, and the superclusters themselves ride the currents of the expanding universe. Even stationary doesn't exist. If you try to hold still, you're just moving alongside something else instead of away from it. Gravity shapes the largest structures, but also carves out the smallest stories. Every rock in space, every grain of dust, every tiny frozen shard drifting in the dark is part of a motion so old you'll never trace it back. Asteroids crash, comets evaporate near stars and freeze again in the dark. Moons break apart, and dust spirals inward over millions of years until it becomes the building material for new planets or the fuel for rings that orbit silently like scars. And silence itself is an illusion. Space isn't void of activity, it's void of medium. With no air to carry noise, the universe communicates through light, energy, and motion instead of sound. If you could translate the signals of cosmic events into something your ears could understand, the universe would roar. The birth of a star would thunder like a furnace devouring mountains. A supernova would crack reality like a billion bombs detonating together. Black holes colliding would send bass rumbles across space-time that would shake everything from planets to atoms. Instead, you interpret those events in wavelengths outside your senses. Infrared reveals the warm dust that hides newborn stars. Ultraviolet shows where young stars burn too hot to see directly. Radio waves map the outer structures of galaxies and the relic radiation left over from creation. X-rays come from the heated edges of black holes and neutron stars. Gamma rays burst from the deaths of massive stars or the collision of stellar corpses. You can't hear the universe, but you can read its voice across the spectrum. Even light itself bends to the universe's will. When it passes near massive objects like galaxy clusters, gravity warps the space it travels through, curving its path. This gravitational lensing creates magnified and distorted images of objects behind the cluster, sometimes showing multiple versions of the same galaxy in different places. It means you're not just seeing the universe, you're seeing its tricks of perspective, its mirrors, its shortcuts, and its echoes. Some objects fool you in other ways. Quasars look like stars in early telescopes, but they're actually the blazing cores of galaxies where supermassive black holes are feeding. Blazars are quasars pointed directly at Earth, their jets blasting radiation across space like fire hoses of light. Magnetars burst with flares so powerful they could wipe out electronics across planets from thousands of light-years away. White dwarfs steal matter from companion stars until they reach a critical mass and explode in supernovas so consistent they're used as measuring sticks for the expansion of space. Yet for every explosion there is stillness. There are galaxies too faint to detect, drifting through filaments of dark matter like embers in fog. There are worlds with no stars, rogue planets flung into darkness, wandering for billions of years in cold silence. Some may still have heat beneath their crusts, their cores slowly cooling as they drift through a night with no dawn. There could be oceans beneath the ice, preserved by pressure or chemistry, where life evolves without ever seeing a sun. Even time doesn't move at the same pace everywhere. Near strong gravity, like around black holes or neutron stars, time slows relative to regions with weaker gravity. If you orbited close to the event horizon and returned, everyone you knew would have aged more than you. Time dilation isn't science fiction. It's measurable and real, already affecting satellites in orbit around Earth. Without adjusting for it, GPS systems would drift out of accuracy in hours, and beyond time as you experience it, there's cosmic time, the slow drift toward entropy. Stars are engines that turn hydrogen into helium, helium into carbon, and eventually iron. When a star can no longer fuse elements to release energy, it dies, either collapsing inward or exploding outward. Over trillions of years, the universe will run out of stars to form. Black dwarfs will cool into invisibility. Neutron stars will sit in silence. Black holes will evaporate. Galaxies will dim and dissolve. In the end, the universe won't end with a bang or a crash, but with a whisper of fading light in an endless night. And yet, improbably, you live in the brief window where light still rules. You exist in the era of stars, of galaxies, of hydrogen burning and elements mixing, of light crossing space to be seen. You emerged at the only time in universal history where beings like you could look outward and ask where you came from. 1 trillion years from now, if any life survives, the night sky may hold no clues about the universe's beginnings. The galaxies beyond the Milky Way may be invisible. The cosmic background radiation may be undetectable. The evidence of everything before will fade into silence. But now, in this chapter of existence, the sky still speaks. The photons still arrive. The gravity still bends. The echoes of creation still hum in microwaves. You don't just live in a universe, you live in the most visible moment of its life. And while your lifetime is shorter than a flicker in cosmic terms, your awareness stretches backward and forward across billions of years, making you something the universe hasn't seen before. Not just matter that moves, but matter that remembers, imagines, and wonders. You aren't separate from the stars. You are their autobiography. Life is not an exception to the universe. It's one of its experiments. Long before humans arrived, long before Earth cooled enough for oceans to form, the ingredients for biology were drifting in space. Complex organic molecules hide in interstellar clouds, clinging to dust grains in the dark between stars. Comets carry amino acids and carbon compounds forged in the cold. Meteorites that fall to Earth still contain building blocks of life, preserved since the birth of the solar system. The universe didn't wait for life, it prepared for it. And when Earth finally formed, it wasn't a quiet nursery. It was chaos. Molten rock, volcanic skies, oceans of fire, constant collisions with asteroids and comets. Yet within a few 100 million years, life appeared in some form. Whether it sparked from chemistry in the oceans, in deep-sea vents, in tidal pools, or delivered by cosmic debris, it emerged quickly and stubbornly. Once it began, it adapted to extremes: boiling waters, toxic gas, crushing pressure, ice, radiation. Life didn't need comfort. It needed opportunity. The rules that govern galaxies and stars are the same rules that drive the cell, the atom, and the heartbeat. The carbon in your DNA was smelted in the core of a star. The nitrogen in your muscles was fused in a different one. The oxygen in your lungs was formed in another. You inhale stellar remains and exhale them in new arrangements. When you touch your skin, you're touching recycled universe. Planets are tiny compared to stars, and stars are tiny compared to galaxies. Yet the surface of a planet is where the universe becomes self-aware. Life might exist deep underground, beneath ice, in methane lakes, in hydrogen seas, or in clouds of gas giants. You don't know how common or rare it is because you've only studied one world closely, but the ingredients, water, carbon, energy, time, exist everywhere. Life may not be an accident. It may be a pattern waiting to happen wherever physics gives it a chance. And the planets themselves show what's possible. Some orbit two suns at once, experiencing strange seasons of double shadows and shifting light. Some orbit red dwarfs so closely that their years last days and their skies glow dim and red forever. Some have no star, drifting in darkness, insulated by thick atmospheres or warm oceans beneath ice. Some might be tidally locked, with one side scorching and the other frozen, life clinging to the twilight band in between. And even your sun is not unique. It's one star out of hundreds of billions in the Milky Way, and the Milky Way is only one galaxy in a universe of trillions. Most stars have planets, many have multiple. Some systems have worlds larger than Jupiter orbiting closer than Mercury. Others have rocky planets bigger than Earth with deep oceans, thick atmospheres, and gravity that would crush you. Even the moons around planets like Jupiter and Saturn are more geologically active than you once thought, hiding oceans, geysers, storms, and tides powerful enough to reshape their surfaces. But you haven't looked everywhere, not even close. The nearest star system, Alpha Centauri, has at least one Earth-sized planet in a habitable zone. Proxima b orbits its small red star every 11 days, bathed in flares and radiation. It may be barren, or it may have adapted, shielded by oceans or magnetic fields. You don't know yet, but the universe isn't subtle. It repeats patterns across unimaginable distances. Even the galaxy has its architecture. Stars gather in clusters, orbit spiral arms, and drift through corridors of gas and dust. Supernovae trigger new waves of star formation by pushing gas clouds into collapse. Stellar nurseries glow in pink and red, lit by the ultraviolet radiation of newborn stars, still wrapped in the remnants of the clouds that formed them. Some systems orbit so densely packed near galactic centers that stars pass within a few light days of each other, their gravity tangling like threads in a knot. Galactic centers themselves are strange realms. Most contain a supermassive black hole millions or billions of times the mass of the Sun. The one in the center of the Milky Way, Sagittarius A star, is quiet now, but once may have blazed with energy as it fed on gas and stars. Other galaxies have cores so bright with accretion disks that they outshine the rest of their stars. And sometimes galaxies fling stars outward at such high speeds that they escape into intergalactic space forever, exiles with no orbit to return to. And beyond galaxies lies the cosmic web, filaments of dark matter and gas stretching across the universe like veins of structure, with galaxy clusters forming at the intersections. Between these filaments lie voids so vast and empty that a galaxy drifting through one might not encounter another for billions of years. Those empty expanses are part of the universe's shape, just as much as the glowing clusters. You live in a universe that is mostly hidden. Most of its matter is invisible. Most of its history is unreachable. Most of its future you won't witness. Yet you occupy the one moment when everything is illuminated, when stars still burn and galaxies still gather, when the sky is full of clues and the night is not yet silent. And for now, the stars still write their stories in photons and gravity. You can see galaxies as they were billions of years ago, their shapes twisted by collisions and time. You can measure the motion of stars in your own galaxy and infer the invisible structures holding them in place. You can listen to the hum of gravity itself as black holes merge in the dark. Even time stretches differently depending on your view. If you could watch the universe from its beginning to its end in fast forward, you'd see stars flare and die like sparks from a bonfire. Galaxies would collide and merge like clouds crashing into each other. Clusters would drift apart as dark energy expanded the space between everything. Eventually, even the light would fade, and the universe would slip into a stillness so final it wouldn't even remember brightness. But that isn't now. Now is the age of radiance, of activity, of discovery. You're alive during the slice of cosmic history where questions can be asked and answers still glow in the dark. The universe doesn't think or plan, but through you it reflects. You're a temporary shape made of ancient atoms, assembled into awareness, watching the fire still burning across the void. Stars don't know their stars. Galaxies don't know their galaxies. But you know you're here, and that makes you the rarest thing the universe has made so far. A witness. The universe doesn't explain itself, but it leaves trails in every direction. Light stretched across billions of years, elemental fingerprints in starlight, the gentle sway of galaxies pulled by unseen mass. These are the clues left behind by events so distant, you'll never witness them directly. Yet from those traces, you've learned to assemble a picture of a cosmos wider, older, and stranger than imagination ever expected. Space isn't still, and it isn't uniform. It has texture and temperature, echoes and scars. The cosmic microwave background, the afterglow of the universe's birth, isn't perfectly smooth. Tiny fluctuations in its temperature are the fingerprints of quantum irregularities amplified by inflation into the seeds of galaxies. From randomness came structure. From structure came stars. From stars came elements. From elements came life. And even now, the radiation from that moment still washes over you. Every part of your body is being passed through by relic photons from 13.8 billion years ago. They carry almost no energy now, cooled to just a few degrees above absolute zero, but they are everywhere, a silent reminder that the universe remembers where it came from even if you forget. Gravity doesn't just shape matter, it shapes time. If you lived near a black hole, your moments would stretch differently than someone far away. To someone watching from a distance, you'd appear to move slower and slower as you approached the event horizon, frozen just before crossing. But from your perspective, you'd keep going, unimpeded, until the universe curved into itself and the laws of physics stopped taking questions. Some black holes spin so rapidly that they drag space-time around them, twisting reality into a whirlpool of rotation. Anything caught too close is forced to move with the spinning space itself, like leaves carried along by a vortex. Around them, disks of matter swirl at nearly the speed of light, heated to millions of degrees by friction and torn apart atom by atom. These objects don't just end stars. They shape galaxies. And not all galaxies age peacefully. Some are cannibals, tearing apart smaller galaxies and absorbing their stars. The Milky Way has done this repeatedly and will do it again. The remnants of devoured galaxies still drift as stretched streams of stars across our halo, quiet evidence of cosmic hunger. One day, even the large Magellanic Cloud may be pulled in and dismantled, its stars redistributed into new orbits among the billions already here. On larger scales, clusters of galaxies form the biggest gravitationally bound structures in the universe. They contain thousands of galaxies, vast pools of hot gas, invisible halos of dark matter, and collisions that play out over hundreds of millions of years. When clusters collide, the galaxies mostly pass through one another, but the gas slams together and heats to hundreds of millions of degrees, glowing in X-rays across intergalactic space. And beyond those clusters is the space between, voids so empty that a ray of light could travel millions of years without brushing past a speck of dust. These voids are not empty of energy, but empty of form, and they grow larger as the universe expands. Fragments of gas and lonely galaxies drift at their edges, stranded between the filaments of the cosmic web. Even motion is relative to perspective. On a cosmic scale, the Milky Way is moving toward the Virgo cluster. And beyond that, everything is being pulled toward a mysterious region called the Great Attractor. But even that is moving towards something larger still, a gravitational anomaly in the Laniakea supercluster. Everything is part of a current of movement so enormous that your entire galaxy is just another grain of dust swept along its path. And while all this unfolds, the stars continue their quiet burning. Some fuse hydrogen gently, lasting tens of billions of years. Others burn furiously, living only a few million years before exploding. The biggest stars live fast and die violently, leaving behind black holes or neutron stars. The smallest barely glow at all, conserving fuel like cosmic misers, fated to outlive every other form of light. Yet starlight isn't the only glow in the dark. There is light created by charged particles spiraling along magnetic fields, by gas heated in the accretion disks of black holes, by matter falling into neutron stars, by the faint glow of rogue planets radiating the last of their heat into surrounding darkness. And even after light fades, motion continues. Gravity doesn't stop when the stars do. Long after the last galaxies dissolve, black dwarfs will orbit one another in silence. Planets, asteroids and debris will fall or drift or freeze. Eventually, after unthinkable eons, even protons, the core of atoms, may decay, leaving behind nothing but a haze of leptons and photons. But that is the universe's distant future. For now, it is rich with movement, heat and memory. The building blocks of life swim in comets, cling to dust, and swirl in newborn systems. The same chemistry that sparked biology here could be dancing in the clouds of distant worlds or beneath surfaces of hidden oceans. Life doesn't need Earth. It needs chemistry, time, and a niche, and the universe is full of niches. Astrobiologists wonder not whether life exists elsewhere, but why you haven't found it yet. The galaxy is old enough for civilizations to have risen and vanished long before Earth formed. There may be ruins on worlds you'll never reach. There may be ecosystems beneath ice sheets thicker than skyscrapers. There may be signals crossing space right now, too faint or too alien to decode. Or life could be everywhere in microbial form, invisible to your instruments, but thriving in silence. And even if humanity never meets another voice, you're still part of a universe that builds complexity from chaos. You're an echo of stars and nebulae, a temporary pattern in a sea of energy. Everything you are, thought, breath, heartbeat, hunger, wonder, is a consequence of cosmic events set in motion before time had a name. Your existence is not a footnote, it is a continuation. You are the universe looking back at itself and briefly recognizing the reflection. The universe didn't need permission to create you. It didn't pause to consider the odds or ask whether consciousness belonged in its design. It just kept unfolding, letting gravity sculpt matter and time stretch energy into form. You exist not because you were planned, but because the conditions were right for atoms to assemble into awareness. And those atoms were forged in places so extreme they tear apart anything less durable than a star's heart. Hydrogen, the simplest element, was born in the first minutes after the Big Bang. Helium followed soon after, but everything else, carbon, oxygen, silicon, iron, gold, calcium, was manufactured inside stars or in their explosive deaths. Every atom in your body heavier than helium came from a star that lived and died long before Earth took shape. Some of those stars were giants, burning bright and short before detonating in supernovas. Others drifted quietly into white dwarfs before flaring into nova outbursts that seeded nearby clouds of dust with fresh elements. Those clouds became new stars and new systems. Earth is second-generation material built from recycled stardust, ash, and metal from supernovae long forgotten. Even the water you drink contains hydrogen older than any star and oxygen born in stellar furnaces. When you breathe, you're recycling ancient light, and the solar system itself is a byproduct of collapse. A cloud of gas and dust gave way to gravity, spinning faster as it contracted, flattening into a disk. The sun formed in the center, while the leftovers clumped into planets, moons, asteroids, and comets. The early solar system was violent, full of collisions and bombardments. Earth was struck by a Mars-sized object, ejecting debris that eventually formed the Moon. That moon has been slowing Earth's rotation and stabilizing its tilt ever since, making climate cycles more predictable and tides more regular. Your oceans and your seasons owe themselves to an ancient impact and the debris it left behind. The planets didn't form politely. Jupiter rampaged through early space, scattering material, swallowing would-be planets and flinging others into the outer reaches. Its gravity shaped the asteroid belt, preventing a world from forming there. It protected Earth from some impacts and sent others hurtling inward, carrying water and organics. Saturn, Uranus, and Neptune migrated from their birthplaces, reshaping the orbits of smaller bodies like shepherds, herding flocks made of stone and ice. And beyond Neptune lies a frontier of frozen worlds, some larger than Mercury, their surfaces marked by methane ice, nitrogen glazes, and cryovolcanoes that erupt slush instead of lava. Past that, in the Oort cloud, trillions of icy bodies move in darkness, waiting for gravitational nudges that may send them sunward as comets, trailing ancient stories in long, shining tails. But stars and planets are only part of the story. The Milky Way itself is a sprawling spiral with arms of stars, gas and dust, rotating around a core where a supermassive black hole waits in the dark. That black hole, millions of times the mass of the Sun, influences the orbits of stars thousands of light-years away. Around it swarm clusters of ancient suns, some nearly as old as the galaxy itself. Farther out, young regions burst with activity, nurseries where baby stars still glow in their gaseous cradles. Yet the Milky Way is not static. It's pulling in dwarf galaxies, tearing them apart with tidal forces and adding their stars to its own. Streams of shredded galaxies wind through the halo like threads unraveling from old cloth. Eventually, Andromeda will join in this merger, forming a new galaxy altogether, though no one alive today will see even the beginning of that collision. And the Milky Way is only one galaxy among trillions. Some are spirals, some are ellipticals shaped like cosmic eggs, some are irregular, smeared by collisions or warped by unseen forces. There are galaxies with supermassive black holes swallowing stars, galaxies without visible stars, their matter hidden in dark halos, galaxies so distant that their light is only now reaching you from a time when the universe was young and chaotic. Beyond them stretch filaments of the cosmic web, structures so large they make galaxies look like sparks. Threads of dark matter hold these filaments together, with gas and stars clumping where gravity is strongest. Between them lie immense voids, regions so empty they make the spaces between planets seem crowded. Your galaxy is drifting through this web, guided by forces you cannot feel and structures you cannot see. The local group of galaxies moves toward the Virgo cluster, which itself flows toward the Great Attractor, and beyond that lies the Shapley supercluster. Everything is in motion, even if the distances make it seem still. And while galaxies drift, time keeps rewriting the landscape of existence. Stars die, planets freeze, black holes grow, and dust collapses again into new beginnings. The universe is a cycle of birth and destruction, a sequence of transformations acting across timescales. Your body cannot grasp, but your mind can chase. You are not separate from that process. You are a moment in it. Every breath is a continuation of ancient energy. Every cell is chemistry drawn from stars. Every thought is electricity shaped by evolution, which was shaped by biology, which was shaped by geology, which was shaped by astrophysics. You are not an interruption in the cosmos. You are one of its sentences. And still, the story continues without pause. Somewhere right now, a star is igniting for the first time. Somewhere else, a world is cooling from molten rock to crusted stone. Somewhere, oceans are forming beneath carbon skies, and somewhere they are evaporating under the anger of a dying sun. You will never see most of it, but your atoms might someday if they're recycled again into something that looks up and notices. You don't need to understand the universe for it to include you. You're already in it, a temporary arrangement of matter observing itself across time. You exist at a scale the universe barely notices, yet you're made of the same forces that steer galaxies. Gravity holds you to the Earth just as it holds stars in orbit. Electromagnetism shapes the atoms in your bones the same way it lights up nebulae. The strong force binds the nuclei of your cells the same way it holds together the matter in neutron stars. The weak force helped power the sun that fed your evolution. The laws that govern quasars and black holes are the same ones writing your heartbeat. Your perception is tuned to survival, not truth. You see a narrow band of light because that was enough to navigate a world under one star. You hear within a limited range because that was enough to detect danger and kin. You move through time in one direction because your brain builds memory based on increasing entropy. But the universe doesn't restrict itself to your senses. It hums in radio waves, whispers in neutrinos, glows in ultraviolet, and bends light with gravity. It operates in dimensions and scales. Your instincts were never meant to know, but your curiosity doesn't care about that. You've extended your reach with machines. Telescopes now see galaxies billions of light years away, capturing their light long after the stars themselves have died or changed beyond recognition. You've built detectors so sensitive they can catch the ripple of space-time from a collision halfway across the universe. You've mapped the background radiation left over from creation itself and found it nearly uniform, with slight variations that seeded everything you've ever known. Your probes drift through the solar system, some already beyond the influence of the sun, carrying with them golden records of sound and music and greetings they will almost certainly never deliver. They are messages in bottles, cast into an ocean so vast that even hope goes silent. And yet, you launched them anyway. Life on Earth has already survived 5 mass extinctions. It endured asteroids, volcanic winters, ice ages, continental drift, supernova radiation, atmospheric changes, and the randomness of evolution. It has thrived in boiling vents, acidic pools, frozen deserts, and the vacuum of space on the exterior of orbiting stations. You are not the first intelligence the planet has produced, but you are the first aware enough to recognize how temporary your presence is. Extinction is not an if, it's a when. Species vanish constantly, and one day humans will too. The Earth will not keep you forever. One day, the continents will shift into new forms, the atmosphere will thicken or thin, the oceans will swell or disappear, and your cities will erode into fossils no different from coral or bone. The universe will not pause to mark the moment. But consciousness gives you a strange privilege, the ability to imagine a future beyond your lifespan. You can build tools that outlast you, write information across generations, and plan for events that won't happen for centuries. You can alter planets and preserve knowledge with technology made from the same minerals that once cooled in magma and drifted as dust. Your understanding of the universe is young, but you've already measured its age, its acceleration, its composition. You've identified exoplanets by the wobble of stars and the flicker of their light. You've traced the elements in your blood back to dying suns. You've watched galaxies interacting, collapsing, and spreading across superclusters. You've modeled the birth of time itself and glimpsed the echo of the beginning in the cold static of the cosmic microwave background. And still, the unknown outweighs the known by orders of magnitude. You don't know what dark matter is. You don't know what dark energy is. You don't know how consciousness arises from tissue. You don't know how common life is across the stars. You don't know if the universe is infinite, cyclical, isolated, or just one of many. You don't know if time had a cause or if cause itself is an illusion. You don't know whether physics will hold forever or tear itself into new laws in the far future. But you're not required to know everything to belong here. Uncertainty doesn't exclude you. It invites you in. You're made of questions wrapped in biology, walking on a world built from dust older than your star. You are temporary, but so is every galaxy, every nebula, every black hole. The only difference is that you notice. Even memory is borrowed. The neurons that store your thoughts are replaced over time. The atoms in your brain today are not the same ones that formed your first memory. Matter cycles, structure shifts, and yet awareness persists for as long as the pattern holds. When it fades, your atoms will scatter and resume older roles, perhaps in oceans or rocks or future bodies dreaming under alien skies. The universe doesn't cling to forms. It builds, transforms, and dissolves. Stars become dust. Dust becomes worlds. Worlds become ruins. Ruins become ingredients. Everything recycles, even if the timeline is too large for you to track. You are not at the beginning or the end. You are in motion, part of a process that started before atoms and will continue after light itself fades. And while you exist, you get to witness the rarest phase of the cosmic timeline, the era when the night sky still tells the truth. You can still see other galaxies. You can still detect the afterglow of the Big Bang. You can still measure the speed of expansion. You are alive during the window of visibility, before distance erases the past from view. In the deep future, civilizations, if any remain, may see only a dark, empty void, with no clue that galaxies once covered the sky like cities of light. They may never know the universe had a beginning, or that it was once full of stars. They may assume they are alone in a silent, static expanse. You live before that forgetting. Your existence is improbable but not impossible. You are the result of physics exploring one of its many options. If the constants of nature were slightly different, you would not be here. But something else might be. And in some other universe, governed by different numbers, something else might be wondering, just as you are, how it came to be. You will not see the universe finish its story, but you are here to read this chapter of it. And that is enough for now. The universe does not slow down for comprehension. It expands whether you understand it or not. It burns stars whether you see them or not. It curves space-time whether you can measure it or not. Humans like to think of existence in human terms, beginnings, middles, endings, but the cosmos doesn't acknowledge your scales. It moves in epochs so vast, your greatest monuments are blinks, and your entire history is a breath lost in wind. But even in this scale, your presence is not meaningless. You're not outside the story, you're written in its ink. Your blood carries iron from supernovae, your bones lock in calcium from dead suns. The air in your lungs was exhaled by dinosaurs and microbes and ancient forests long turned to stone. The photons hitting your eyes each night began their journey before your species had language. You are continuously interacting with cosmic history without noticing, and the sun that sustains you is a mid-tier star in a quiet suburb of one spiral arm of the Milky Way. It's not the brightest, largest, or oldest, but it's stable enough to give lifetime to evolve. It fuses 600 million tons of hydrogen into helium every second. The light that reaches Earth left the core thousands of centuries ago, fighting its way through dense plasma before escaping into space. When it touches your skin, you're feeling energy released before humans existed, before mammals existed, back when the planet was still reshaping itself. The Sun is halfway through its lifespan. In another 5 billion years, it will swell into a red giant. Before that, its brightness will slowly increase, making Earth less habitable long before the final transformation. The oceans will evaporate, the atmosphere will burn, the crust will crack. Long before the Sun becomes a red giant, life as you know it will be gone or forced to flee. But stars die differently based on their mass. Small stars, red dwarfs, can burn for tens or hundreds of billions of years, far longer than the current age of the universe. Massive stars live quickly and die spectacularly, forging heavy elements before collapsing or detonating. Some leave behind neutron stars, spinning so fast they flash beams of radiation like celestial lighthouses. Others create black holes, invisible except for the violence at their edges. And all these stars orbit within galaxies that are themselves in constant motion. The Milky Way spins every 225 million years. That means dinosaurs walked the Earth the last time our solar system was on the other side of the galaxy. When Earth formed, the galaxy was young and shaped differently. Stars were arranged in denser clusters. Supernova rates were higher. Comets and asteroids were more common. Life developed in a minefield and still found a way. Galaxies drift toward one another, pulled by gravity and pushed by dark energy. Some collide and merge. Some pass close enough to rip stars away from each other. Some lose their gas and stop forming stars entirely, fading into quiet collections of ancient suns. Some isolate in voids, alone for billions of years, with no neighbors to disturb them. And then there are the galaxies you cannot see at all. Some are hidden behind dust, some are too faint to detect, some are so far away their light has stretched into invisibility. Others have already crossed the horizon of the observable universe and are now receding faster than light, not by speed through space, but by the expansion of space itself. Their photons still travel, but space expands beneath them, making the journey longer than time allows. Even the concept of empty space misleads you. Vacuum is not silence, it's seething. Fields permeate all of space-time. Virtual particles appear and vanish in instants. Some pop into existence in pairs, only to annihilate again before they can be seen. Energy exists in forms you cannot measure directly, and the vacuum itself may drive the expansion of everything. The quantum world that underlies reality is not intuitive. Particles are not little balls. They are excitations in fields, probabilities expressed through interaction. They do not have positions until measured. They do not move the way objects do. They blur, tunnel, flicker, and entangle. Two particles separated by light years can affect each other in ways that ignore distance entirely. Your mind evolved to throw rocks, not interpret wave functions, yet here you are, building theories that describe phenomena no sense organ has ever directly perceived. And still, your own existence ties you back to the smallest scales. Your body is constructed from quantum rules. Chemistry is quantum mechanics wearing the mask of predictability. Biology is chemistry at scale. Evolution is biology stretched through time. Thought is biology generating pattern. Civilization is thought given hands, words, and hunger. The same physics-forging stars has built systems capable of writing symphonies, building telescopes, doubting gods, and landing metal machines on other worlds. The substance of the cosmos has turned inward, reflecting on itself through creatures made of its dust. And while the universe is grand in scale, its future is already written in probabilities. Stars will continue to form only as long as gas remains. Eventually, the raw material will run out or be locked away in remnants. Galaxies will fade, clusters will drift apart, even black holes will evaporate, radiating energy until they vanish. Matter itself may decay. One day, there will be no stars, no planets, no atoms, only radiation spread thin across expanding darkness. But you live in the middle, not the end. You live in the incandescent chapter, the age of fusion and light, the brief window when stars burn and galaxies glow, and planets host oceans, mountains, bacteria, trees, and minds. You live during the most visible fraction of the universe's existence, when the past is still detectable and the future has not yet dimmed everything to twilight. You don't need eternity to matter. You exist now, while existence can still be witnessed. And even when your atoms leave your body and rejoin the cosmos in other shapes, they will still be part of this story, just spoken in a different sentence. The universe is vast, but that doesn't mean it's empty of meaning. Meaning is something consciousness projects onto reality, not something stars are required to provide. You exist in a cosmos that doesn't speak your language, yet you've learned to translate its patterns, light curves, spectral lines, orbital shifts, gravitational ripples, into understanding. You turned silence into data, and data into story. The universe doesn't acknowledge that, but it doesn't need to. The fact that you can notice is enough. Even your location in the galaxy is temporary. The Sun moves through different regions as it orbits, sometimes passing close to nebulae or star clusters, sometimes traveling through sparse areas. There are theories that mass extinctions on Earth might be linked to these journeys, perhaps from increased comet activity or bursts of cosmic rays. Over millions of years, your solar system drifts through densities and dangers without your awareness. Space is not static, it's migration. And even within the solar system, orbits are not perfect circles. Planets tug on one another, moons stretch their hosts, tides move rock and water, Jupiter pulls comets from the dark. Saturn's rings are constantly restructured by shepherd moons that prevent them from collapsing or dispersing. Uranus is tilted on its side from an ancient collision, and Venus spins backward for reasons still debated. Neptune captured Triton from the Kuiper Belt and now holds it in a slow spiral of doom that will eventually tear it apart into rings. The diversity of worlds is staggering. There are exoplanets with iron rain, glass storms, diamond mantles, and atmospheric rivers of metal vapor. Some orbit their stars so closely that a year lasts hours. Others drift so far that a season could last a human lifetime. Some are swollen from heat, larger than they should be, and some are compressed by gravity into extreme densities. There are planets with 3 suns, planets with none, planets that were once moons, and moons that should have been planets. And beyond planets, the interstellar medium is rich with chemistry. Clouds of dust and gas contain alcohols, amino acids, and complex carbon chains. There are molecules floating in space that would shatter if exposed to Earth's environment. They exist in frigid darkness, shielded by nothing but distance and cold. Galactic winds carry them across light years, and gravity eventually sweeps them into the formation of new systems. Comets act as couriers, delivering frozen cargo from the outskirts to the warm inner zones. Some burn up, some crash, some seed atmospheres with carbon compounds that can spark biology. The line between geology and chemistry blurs, and the line between chemistry and biology is thinner than you think. Life is not a separate category from physics, it is one of its clever outcomes. And awareness is not a default state. Intelligence is not required for complexity. The vast majority of the universe operates without witnesses. Stars burn without admiration. Galaxies collide without commentary. Black holes devour without malice. Existence proceeds whether or not something is there to interpret it. Yet interpretation adds a new layer that did not exist before. You are a node of perception moving through space-time, and you carry the gift and burden of knowing. You know that your time is limited, your perspective incomplete, your body fragile, and your reach minimal compared to stars. Yet you also know that atoms do not think, but you do. Stars do not dream, but you can. Light does not wonder where it's going, but you ask the question anyway. Even language, your tool for shaping thought, is a phenomenon the universe never planned for. It's a byproduct of survival, turned into a method for exploring existence. You name constellations not because the universe needs labels, but because your mind needs anchors. You draft models of reality not because reality requires them, but because your curiosity does. And curiosity might be one of the rarest forces in the cosmos. It moves you beyond survival, beyond instinct, into realms of abstract imagination where you simulate futures, decode pasts, and explore distances your body will never reach. It drove you to split atoms, build machines that outfly birds, and simulate the birth of space itself. But you're not alone in this curiosity. Other species on your planet navigate stars, build tools, communicate across generations. Intelligence is not binary. It is a spectrum, and evolution is not done experimenting. Somewhere on another world, under different skies, curiosity may be growing in silence, waiting for eyes or sensors or instincts sharp enough to see beyond hunger and shelter. Yet the silence of the universe is unnerving. The Fermi paradox asks, if the cosmos is so full of stars and planets and time, where is everyone? There are answers, but none are comforting. Maybe life is common and intelligence rare. Maybe intelligence is common and technology rare. Maybe civilizations rise and die before they can spread. Maybe they hide. Maybe they were here and left. Maybe they are too alien for you to detect, or maybe you are early. The observable universe contains more planets than grains of sand on Earth. Even if life arose on only a fraction of them, there should be billions of biospheres. But distance is a wall, time is a filter, and communication is a fragile thread. The fact that you haven't heard anyone doesn't mean no one is speaking. It might mean you haven't learned to listen in the right direction. But even if you never find a voice besides your own, you are not isolated. The atoms that make you have touched stars, meteors, oceans, and clouds. The photons you see come from distances beyond imagination. The elements in your blood are older than Earth. The calcium in your teeth once compressed in the heart of a dying star. You are not separate from the universe. You are entangled with it, shaped by it, recycled through it. And long after you are gone, long after your species is gone, long after your planet is gone, your atoms will continue. Maybe they will fall into the sun. Maybe they will drift into space. Maybe they will join a comet or seed another world. Maybe they will sink into a black hole and later evaporate as radiation. You will end, but your matter won't. You will dissolve, but your story will continue in particles you will never meet. Meaning is not granted by eternity. Meaning is granted by awareness. You are here now, alive during the luminous era of the universe, able to see stars before they vanish, able to feel gravity before time dilutes motion, able to think before silence takes over. And that is not small, that is staggering. You live in a universe that reveals itself in fragments, not full views. Every discovery is a sliver peeled back from an incomprehensible whole. You see only the light that reaches you. You detect only the particles that interact. You infer everything else from the motion of things you can measure. Yet from these fragments, You've learned to map the unseen and predict the invisible. Dark matter is one of those invisible architects. You don't see it, touch it, or absorb it, but you see what it does. Galaxies spin too fast for visible matter alone to hold them together. Stars at their edges should be flung into space, but they're not. Something massive, unseen, surrounds them like scaffolding. It doesn't glow, reflect, or absorb light, but it shapes motion across billions of light years. It's not a flaw in observation. It's a feature of existence. Most of the matter in the universe is not the kind you're made of. And then there's dark energy, a force even stranger. It isn't pulling things together, but pushing them apart. Space itself is expanding, and that expansion is accelerating. Galaxies that are already far away will one day recede faster than their light can reach you. The night sky you see now is temporary. Over billions of years, galaxies will disappear from view one by one, not because they die, but because distance outruns illumination. Your place in time determines what you can know. If you lived 100 trillion years in the future, you might believe the Milky Way was the only galaxy in existence. The cosmic microwave background would have faded beyond detectability. The expansion of the universe would appear imperceptible. The Big Bang might seem like a myth. You exist in the narrow window when the evidence is still visible and the night sky still speaks. And the night sky is not quiet, it's layered with history. When you look at the Andromeda Galaxy, you see light that left 2.5 million years ago when early humans walked the Earth. When you observe more distant galaxies, you're watching light that left when Earth was molten or before Earth existed at all. The most ancient light you can detect, the cosmic microwave background, comes from a time when the universe was only 380,000 years old, before stars, before galaxies, before atoms had fully formed. You're not looking into space, you're looking into time. Time itself is elastic. It bends and distorts near mass and speed. A clock on a fast-moving ship ticks slower than one on the ground. A clock near a black hole slows compared to one far away. If you watched someone fall toward a black hole, you'd see them slow down and fade, never reaching the event horizon from your perspective. But from theirs, time would continue normally, until physics itself lost definition. Even space bends under gravity. Light curves around stars, galaxies, and clusters, revealing mass that cannot be seen directly. Entire galaxies are lensed into arcs and rings by the gravity of objects in front of them. Some of the most distant galaxies were discovered not by sight alone, but by their distorted reflections bent through space by gravity. And the structures you see today are the result of ancient quantum fluctuations, tiny differences in density that inflation stretched across cosmic scales. Those fluctuations became the seeds of galaxies, clusters, and filaments. Without them, matter would have remained evenly spread, and the universe would be dark and lifeless. Imperfection created everything you know. Your solar system is one drop in this ocean. The planets orbit in a thin disk around the sun because the cloud that birthed them flattened as it spun. Gravity pulled dust into clumps, clumps into rocks, rocks into worlds. Jupiter consumed most of the leftovers, and what remained became asteroids, comets, and dwarf planets. The gas giants formed first, sweeping the outer system, while the inner planets took shape from heavier elements closer to the newborn sun. Earth didn't begin as a place for life. It began as molten rock pummeled by debris. Volcanic gases formed an atmosphere without oxygen. Comets and asteroids delivered water and organics. The crust cooled. Oceans formed. Chemistry sparked complexity. Over billions of years, life adapted to ice ages, firestorms, impacts, extinctions, supercontinents breaking and reforming, oxygen blooms and collapses. Life didn't arrive fully formed. It clawed its way upward through catastrophe. And intelligence is not the universe's goal, it's one of its side effects. Your ability to ask questions is the result of neurons firing in patterns shaped by evolution, which was shaped by environment, which was shaped by planetary history, which was shaped by stellar death, which was shaped by galactic formation, which was shaped by forces set in motion at the birth of time. You did not appear outside the universe. You grew out of it, and now you send signals into space, unaware if anyone will ever hear them. You listen for patterns in radio noise, hoping for intent. You search for biosignatures in the atmospheres of distant planets, not knowing whether life is common or rare. You wonder whether intelligence has risen and vanished countless times before, erased by disaster or apathy, leaving behind no message durable enough to survive cosmic time. Distance is a barrier. Even if a civilization lived 10,000 light-years away, any message exchanged would span millennia. They could be extinct before your reply arrived, or you could be gone before theirs does. Communication across the stars is not conversation. It is archaeology played forward. But the silence doesn't mean loneliness. The atoms in your body have crossed stars, worlds, and eons. The gravity that holds you is the same that shapes galaxies. The light that warms you is the same that nourishes worlds you will never see. You are not observing the universe from outside. You are inside it, built of it, and returning to it. And no matter how small you feel in comparison, your awareness is a phenomenon as real as any star. The universe does not think or feel, but through you it contemplates itself. Through your eyes it sees. Through your mind it wonders. Through your life it exists not just as matter, but as meaning. You don't need the universe to notice you for your existence to matter. You are the noticing. Existence is layered, and most of it works in ways your senses can't perceive. The universe doesn't announce its mechanics. It speaks in gravity, radiation, and motion. Everything from the orbit of a moon to the decay of a particle is part of the same underlying physics, unfolding whether or not anyone is there to witness it. You're not required to see something for it to shape you. Cosmic rays pass through your body every second. Neutrinos from the sun stream through you by the trillions. Dark matter drifts through Earth as if matter were mist. Space itself stretches beneath your feet. Even the idea of down only works because you live on a planet with gravity pointing inward. There is no universal up or down, only directions defined by mass. If you stood on a planet orbiting another star, you'd point in a different down. If you floated in interstellar space, down would stop existing. If you fell into a black hole, even direction would collapse with you. And the universe isn't quiet on small scales. It's frantic. Protons and electrons aren't solid marbles. They're fields of probability. Energy and matter convert into each other constantly under the right conditions. Particles pop in and out of existence in the vacuum. Radioactive decay reshapes atoms over time. Fusion powers stars by overcoming the repulsion between protons, while fission tears apart heavy elements into lighter ones. The chemistry in your blood and breath is quantum behavior slowed down and disguised as routine. Even atoms have history. Hydrogen has existed since the universe was minutes old. Helium too. Carbon had to wait for stars to form and die. Gold had to wait for neutron stars to collide or supernovas to detonate. Uranium had to wait for rare environments where immense neutron flux could occur. Every atom above helium is a latecomer, built in violence and scattered by destruction. And light. Light is the traveler that tells you where you are. It moves faster than anything else, but even it has limits. When you look into the sky, you're not seeing the present. You're watching the past projected outward. The farther you look, the older the light. Some galaxies you observe today no longer exist in the form you see. Some stars you admire might already be dead. Space and time are not separate. They are a woven landscape, and light walks its contours like a messenger carrying news that's already outdated. But not all light is visible. Infrared reveals heat and hidden stars shrouded in dust. Ultraviolet exposes energetic newborn stars. X-rays map black holes, neutron stars, and superheated gas. Gamma rays betray the deaths of massive stars and cosmic collisions. Radio waves show the structure of galaxies and the whispers of hydrogen clouds. You don't see most of the universe because your eyes were built for survival, not astronomy. Even your planet glows. Earth emits infrared radiation into space, the heat of sunlight absorbed and re-radiated. The atmosphere glitters with lightning and auroras, energy dancing along magnetic lines. The core spins, generating a magnetic field that shields you from solar wind and cosmic rays. Without it, your atmosphere would have been stripped away like Mars. You exist in a bubble of invisible protection, forged by molten metal and motion. Life adapts to what the universe gives. Creatures evolved eyes tuned to the sun's peak output, ears tuned to the vibrations of air, skin tuned to temperature ranges Earth can sustain. But your technology extends your body's limits. You can now see in wavelengths your eyes cannot, hear signals your ears can't detect, and simulate environments that don't exist on your world. You've learned to bend light with lenses, trap atoms with magnets, and catch particles that ghost through everything. You've extracted the age of the universe from the glow that still lingers after its birth. You've measured the wobble of stars to find planets around them. You've seen the silhouette of black holes without touching them. You've detected the tremors of space-time caused by collisions older than language. And still, your knowledge is surrounded by everything you don't know. You don't know whether time had a beginning or if the Big Bang was just one in a chain of cycles. You don't know whether dark matter interacts in ways beyond gravity. You don't know whether dark energy will stay constant or change over time. You don't know if life began once or 1,000 times on Earth before it stuck. You don't know whether consciousness is a rare anomaly or an inevitable phase of matter. You don't know if intelligence elsewhere would even be recognizable to you. You don't know if humans are early, late, or alone. But uncertainty doesn't weaken your place in the universe. It defines it. You are not an observer standing outside an equation. You are written into it, an emergent property of ancient reactions. The universe didn't design you, but it allowed you, a temporary convergence of stardust and structure capable of asking questions of the stars that made you. And when your body is gone, your atoms will scatter into air, water, soil, and space, returning to the same cycles that built everything. You don't vanish, you change context. The calcium in your bones might help build a shell or a mountain. The iron in your blood could seed a planet or fall into a star. The carbon in your cells might drift into space and one day help form life again elsewhere. Awareness ends, matter continues, and time keeps writing. So you don't need the universe to acknowledge you. You are already part of its memory, imprinted not in words but in atoms, action, and influence. You exist in the same story as galaxies and quasars and photons and voids. You are a sentence in its unfolding paragraph. What you do with your moment is the only part the universe leaves up to you. You exist in a universe built on tension between gravity pulling matter together and expansion pushing space apart, between heat and cold, order and entropy, light and silence. Stars form in collapsing clouds, even as the universe stretches those clouds thinner. Planets cool while their cores still churn. Galaxies collide while dark energy drives them away from one another on the grand scale. Creation and dispersal happen at the same time because neither waits its turn. Gravity is the sculptor that never sleeps. It pulls dust into clumps, clumps into boulders, boulders into planets. It gathers hydrogen into spheres massive enough to ignite fusion. It bends light, shapes orbits, drives collisions, and slows time itself. It pulls on you every moment, holding your feet to a planet that spins at 1,000 miles per hour and orbits the sun at nearly 67,000 miles per hour. You don't feel that motion because everything around you is moving with you. Stillness is an illusion built from shared velocity. Even the earth beneath you is not solid or still. The crust shifts on molten rock, dragging continents across the globe over millions of years. Mountains rise and erode. Oceans appear and vanish. Volcanoes rewrite coastlines. Earthquakes remind you that stone is not permanent. The ground is a temporary skin over a restless interior. This planet is ancient but not static. It has frozen over more than once, turned tropical more than once, and been nearly sterilized by impacts and eruptions. Yet life adapted through each catastrophe, changing form, strategy, and structure. Mass extinctions wiped out most species more than once, but what survived seeded new eras. Your existence is the result of chance stacked atop disaster, persistence hidden in extinction. You walk on a world shaped by impacts as much as by heat. The moon is a monument to one of those collisions, a scar that became a companion. It slows Earth's rotation and pulls the tides, creating the conditions that shaped coastlines, climates, and migration patterns. Without the moon, days would be shorter, seasons less stable, and the evolution of complex life might have followed a different or impossible path. The sun, steady as it seems, is an engine of chaos wrapped in light. Magnetic fields twist and snap across its surface, releasing solar flares and coronal mass ejections that can knock out power grids and bathe planets in radiation. Solar wind flows constantly outward, a stream of charged particles that shapes planetary atmospheres and sculpts tails on comets. The heliosphere, a bubble carved in interstellar space by the sun's influence, protects the inner planets from some cosmic radiation, but not all. Beyond that bubble, space becomes harsher. Cosmic rays, high-energy particles from distant explosions, travel across the galaxy and through your body. Most are deflected by magnetic fields, but some strike the atmosphere and cascade into showers of secondary particles. They alter DNA, trigger mutations, and contribute to the slow churn of evolution. Radiation is both destroyer and sculptor, and beyond your system are billions more. Some stars are solitary, others exist in binaries or trinaries, locked in gravitational dances that can tear planets apart or stabilize them in long, looping orbits. Some stars are born in clusters and later drift apart, their siblings lost among spirals of light. Others remain bound for billions of years, circling a shared center like two minds locked in a single thought. Between stars, not nothing but dust and gas. Hydrogen atoms drift for light years before finding company. Molecules cling to icy grains in interstellar clouds. Shockwaves from supernovas compress them into new star nurseries. The cycle resets without sentiment. Galaxies do not live alone. They orbit one another in clusters, bound by dark matter. They collide, merge, cannibalize, and distort each other across millions of years. Some cluster cores glow with gas, heated to millions of degrees. Others spin filaments of stars like webs strung across darkness. And in their centers, black holes lurk in silence, feeding occasionally, waiting eternally. Yet even black holes are not eternal in the way you imagine. They evaporate slowly, leaking energy over incomprehensible timescales. For stellar black holes, that process is longer than the current age of the universe by a factor so large it breaks intuition. But time doesn't care about intuition. Entropy will eventually take everything, even the giants of gravity. In the meantime, stars continue to burn. Some flicker with instability, swelling and shrinking in cycles that serve as cosmic distance markers. Others pulse with radiation bursts so strong they could sterilize a planet from afar. Some stars lose their outer layers gracefully, forming nebulae that glow around shrinking cores. Some detonate so powerfully that they leave behind nothing but a shockwave and enriched dust. And the light from those deaths travels across billions of years, carrying encryption keys to the past. You decode them with telescopes, prisms, and equations. You read the temperature, motion, and composition of stars you've never seen up close. You catch the shadows of planets crossing stars and infer worlds that may have oceans, atmospheres, and weather. You exist in a moment where technology has outpaced instinct. Your senses cannot see galaxies colliding, but your machines can. Your body cannot survive space, but your probes do. Your voice cannot cross interstellar distance, but your signals have already left the solar system. And still, everything you know is a grain of sand on an endless shore. You haven't seen most of the planets in your galaxy. You haven't mapped most of the stars. You haven't heard most of the signals. You haven't asked most of the questions. Yet the fact that you can ask at all is extraordinary. Matter arranged itself into cells, into organisms, into minds that build language and map the invisible. You are not an accident in the sense of randomness. You are an expression of physics exploring possibility. And the universe is not done exploring. You stand in a universe that hides most of itself not out of mystery, but out of indifference. 95% of all existence is invisible to you. Dark matter you can't touch, and dark energy you can't sense, both dictating the motion of galaxies and the fate of space-time. What you call normal matter, the atoms that make planets, stars, oceans, and bodies, is only a trace ingredient scattered thinly across an expanding void. And yet that trace builds worlds. Gas and dust coalesce into stars, and around those stars, debris swirls into planets. Some remain barren, scorched or frozen or cracked apart by tidal forces. Others develop atmospheres, weather systems, and chemistry that tiptoe toward biology. Earth is one such world, neither the first nor the only candidate, but the one you know because you arose from it. Your planet orbits at just the right distance for liquid water. Not too close to boil it off, not too far to freeze it all. But this luck is not perfection, it's contingency. Earth has survived asteroid bombardments, volcanic winters, supercontinent breakups, and solar fluctuations. It has been nearly uninhabitable more than once. But life endured, clinging to vents, caves, oceans, and ice, until conditions shifted and new forms emerged. Even now, the planet is changing. The continents continue to move. The core continues to spin. The atmosphere shifts with biological and geological influence. Oceans trade heat with air and ice. Storms redistribute energy across latitudes. Nothing is fixed because fixed things do not last. Everything is in orbit around something. Earth around the sun around the galaxy's center, the galaxy around a gravitational nexus shared by others. Even galaxy clusters drift within superclusters, drawn toward unseen masses. The entire observable universe is in motion, expanding at a rate that increases over time, with every galaxy receding from every other unless bound by local gravity. But expansion doesn't stretch things already held together. Atoms stay intact, planets stay round, stars stay compressed. Galaxies keep their structure until gravity's influence becomes weaker than the accelerating pull of dark energy. One day, the expansion may tear even superclusters apart, leaving galaxies isolated and alone in an ever-growing dark. And that darkness is not empty. Space is full of particles, radiation, and fields. Virtual particles appear and vanish. Photons travel until absorbed or stretched into wavelengths so long they become whispers of heat. Gravity connects everything, even across distances where no light can travel fast enough to keep up. You live in the age when the night sky is honest. You can still see light from galaxies billions of years old because it hasn't yet stretched beyond visibility. In the far future, distant galaxies will fade from view, and observers then will think the cosmos is small and static. They will not know what was lost unless your kind leaves them a trace, but traces degrade, stone erodes, metal corrodes, signals dissipate, orbits decay, languages vanish, memory fades, even stars shift positions over time. The constellations you recognize will distort in tens of thousands of years and become unrecognizable in a million. In a billion, the sky will be entirely different. The galaxy itself will evolve. The Milky Way and Andromeda are on a collision course, due to merge in about 4 billion years. The night sky will fill with new arcs of light, starbursts, and swirling arms. Black holes at the galaxy centers may merge, releasing gravitational waves across space-time. Planetary systems may be disrupted or flung into intergalactic space. All of this will happen long after Earth becomes uninhabitable, long after your species is gone or transformed. Yet the atoms that once formed your cells may still exist, drifting through interstellar clouds or falling inward toward new stars. This is not pessimism, it is scale. Even stars have life cycles. Low-mass stars burn slowly and may last longer than the universe has existed so far. Medium stars, like the Sun, will swell into giants and shed their outer layers, leaving behind white dwarfs made of carbon and oxygen, cooling over trillions of years. Massive stars burn fast and die young, collapsing into neutron stars or black holes, detonating as supernovas that scatter the elements of future planets. And in those explosions, heavier elements are formed: gold, uranium, iodine, platinum. Without those violent deaths, no bones, no blood, no mountains, no circuits, no cities. Destruction is part of formation. Even black holes, the great consumers, are not immune to time. Hawking radiation suggests they leak mass slowly, shrinking across eons. Stellar black holes might take 10 to the power of 64 years to evaporate. Supermassive ones could take 10 to the power of 100 years or more. When the last one dies, the universe may be cold and sparse, with no stars left to warm anything. But you are not living in that era. You exist during the bright fraction of cosmic history when stars still burn and galaxies still shine. You exist when matter is structured and energy is active, when planets can host water and life can arise to witness it. You live in the only time when the universe can reflect on itself from within. And even if you never leave your planet, you have already touched the stars. Your technology has carried fragments of humanity beyond the heliosphere. Your signals have left Earth at the speed of light, spreading in expanding spheres no ear will likely hear. Machines you built orbit other worlds, map their surfaces, taste their air, and listen for quakes. Yet all of it is small compared to what remains unknown. The universe has not revealed most of its secrets. You haven't seen the structure beyond your cosmic horizon. You haven't experienced dimensions beyond the ones you sense. You don't know how many universes exist or whether time itself is one branch among many. But this ignorance is opportunity. A finished universe leaves no room for wonder. The mystery is part of your inheritance, as real as gravity and starlight. You do not need omniscience to belong. You belong because you are made of the same story you are trying to read. The universe is not a single environment, it's layered in extremes. At one scale, stars roar and galaxies collide. At another, particles flicker in and out of existence in silence. Between them lies everything you know, anchored by rules that apply everywhere yet behave differently depending on scale and context. You exist in the middle, where atoms can form complexity and temperatures allow structure to persist without collapsing or evaporating. You think of space as cold and empty, but most of the universe exists at temperatures close to absolute zero. In interstellar space, particles are separated by vast distances, moving slowly through the dark. Yet even there, heat and light pass through like echoes of distant violence. Supernova shockwaves, starlight scattering through dust, gamma-ray bursts from dying giants. Stillness is never absolute. Gravity pulls matter into filaments across the cosmos, forming a web of galaxies separated by enormous voids. The largest structures are clusters and superclusters, bound by dark matter and stretched by expansion. These formations are so vast that light takes hundreds of millions of years just to cross them. You can map them, but never see them all, because the universe is not static. It's expanding while you observe it. And inside galaxies, stars form in clouds of gas, dense enough to collapse under their own gravity. These nurseries glow in infrared, hiding infant stars behind dust that only specialized instruments can see through. Some stars form alone, others in groups, and some in clusters so dense that collisions and mergers are common. Radiation, winds, and jets from these young stars carve cavities and sculpt the surrounding gas into pillars, waves, and arcs. The stars that form determine what comes after. Low-mass stars burn slowly and live for billions or trillions of years. High-mass stars burn hot and die young, exploding as supernovas that scatter their enriched guts across the galaxy. The debris from one generation seeds the next, and the planets that emerge inherit the chemistry of ancient explosions. Planets themselves form from disks of dust and gas swirling around new stars. Gravity and chance decide their fate. Some become gas giants, others rocky worlds, some icy spheres with oceans hidden under crusts. Some are tidally locked, showing one face to their star. Others tumble chaotically through tilted orbits. Some hold atmospheres, others lose them to stellar wind or temperature. A world's habitability depends not on perfection, but on balance. Life emerges not in ideal conditions, but in possible ones. On Earth, life began before the planet was stable, in oceans struck by lightning and warmed by vents pushing minerals into chemical reactions. It endured impacts, climate shifts, and atmospheric changes. It climbed from water to land, then back again. It flew, swam, crawled, and vanished in cycles of extinction and emergence millions of years long. The universe does not favor life, but it allows it. The laws that enable stars also enable chemistry. The same fusion that powers suns creates the elements that form cells. The same gravity that binds galaxies allows planets to hold on to air and water. The same radiation that can destroy also mutates and drives adaptation. Life is not separate from cosmic forces. It is one of their outcomes. And intelligence is an experiment, not a guarantee. Millions of species have existed on Earth, yet only one has built machines, cities, and telescopes. Others communicate, strategize, solve problems, and grieve, but none have shaped the planet the way your kind has. Intelligence comes not from destiny, but from collision, biology meeting opportunity in the right window of time. You now use that intelligence to look outward. Telescopes scan for exoplanets, reading atmospheres for traces of life. Oxygen, methane, water vapor, combinations unlikely to form without biology. Radio arrays listen for signals not made by storms or stars. Spacecraft carry instruments farther from Earth than any life has ever traveled. Rovers crawl across alien soil. Orbiters map worlds with canyons bigger than any on Earth and volcanoes taller than Everest. And still, you've barely begun to explore your own cosmic neighborhood. The nearest star after the Sun is 4 light-years away, 40 trillion kilometers. Your fastest probe would take tens of thousands of years to reach it. Interstellar travel is not a technical inconvenience, but a challenge set by physics itself. Space is not large in the way mountains are large. It is large in the way time is long. Yet you send signals anyway. You name exoplanets you will never step on. You simulate climates of worlds you cannot touch. You wonder about beings who may look at their sky and ask the same questions. Maybe they exist, maybe they vanished, maybe they haven't emerged yet, maybe they're too far away, or too different, or too quiet for you to detect. Distance doesn't erase connection. The atoms in your blood came from stars that died before the sun formed. The photons you see at night began their journey before your species existed. Every breath you take holds molecules that have passed through forests, oceans, bodies, and storms for billions of years. You are not an outsider to the universe. You are one of its expressions. You don't need to cross the cosmos to belong to it. You already do, and the story is not finished. Stars still form, galaxies still evolve, worlds still change. The laws that built everything you know are still at work, everywhere, always. You exist in their wake, in their momentum, in their possibility. Your life is a moment in cosmic time, but not an accidental one. It is the result of forces that began before atoms, unfolding through stars, planets, and oceans, culminating in eyes that can see and minds that can question. And the universe, indifferent yet consistent, continues without pause, carrying you with it whether you realize it or not. The universe does not pause for comprehension. It moves in scales you can barely imagine, but you exist within those scales, whether you understand them or not. You are shaped by forces you cannot feel and surrounded by structures you cannot see. Yet even in your smallness, you are connected to everything, from the quantum flicker of a particle to the slow drift of galaxies across expanding space. Galaxies themselves are not permanent shapes. They warp, collide, merge, and unravel. Spiral arms twist over time, elliptical galaxies swell and fade, dwarf galaxies orbit larger ones like satellites, sometimes stripped apart by gravity and absorbed. Streams of stars stretch through the dark as remnants of these encounters, tracing the invisible scaffolding of dark matter that holds everything together. Dark matter does not glow or absorb light, yet its mass outweighs all visible matter by more than 5 times. It determines how galaxies form, how they cluster, how they spin. Without it, stars would fly apart from their own momentum, and galaxies would unravel before ever forming structure. You know it exists not by seeing it, but by watching what it does. It is the ghost architecture of the cosmos. Even more elusive is dark energy, the force driving the acceleration of cosmic expansion. It acts not like gravity, but against it, pushing space apart faster over time. Galaxies that are distant now will one day be unreachable even by light. The observable universe is shrinking in what you can eventually influence, even as it grows in total volume. One day, only your local group of galaxies will remain visible. The rest will fade beyond detectability, not because they vanished, but because their light can no longer reach you. But the sky above you today is not the same sky that ancient humans saw. Stars move over time, drifting subtly across the firmament. Over thousands of years, constellations distort. Over millions, the entire pattern of the night changes. The North Star was not always Polaris, and will not remain so. The Earth wobbles on its axis over cycles of tens of thousands of years, changing the tilt of seasons and the rhythm of climate. And climate itself is a cosmic process. Earth's atmosphere was not always breathable. Oxygen was once a deadly poison to early life. The air you rely on was made by organisms that transformed the planet without intention. The continents you know were once joined in supercontinents like Pangaea and Nuna, only to split and drift again. Oceans formed, vanished and reformed. Ice ages came and went. The world is ancient, but never static. Your species has existed for only a fraction of cosmic time. If the universe were compressed into a single year, humans would appear in the final seconds before midnight on December 31st. Civilization would occupy the last blink. Yet in that blink, you've learned to read the age of stars, the curvature of space-time, and the echoes of the Big Bang itself. You have discovered planets orbiting distant suns by measuring tiny dips in brightness or subtle wobbles in motion. You have imaged exoplanets directly, faint dots lost in the glare of their stars. You have found worlds in habitable zones where temperatures may allow liquid water. Some are larger than Earth, some smaller, some scorched, some frozen, some likely covered in thick atmospheres or endless oceans. You name them, catalogue them, and wonder which might hold life. The search is not confined to looking outward. Within your own solar system, moons like Europa and Enceladus hide oceans beneath ice, warmed by tidal forces. Saturn's moon Titan has lakes of methane and complex organic chemistry. Mars once had rivers and seas. Even Venus, now hellish, may have once been temperate. Life may not be as rare as your distance blindness suggests. And if life forms elsewhere, it will face the same universal laws: radiation, gravity, thermodynamics, entropy. But its shape, chemistry, and perception may be nothing like yours. It may not build tools or speak or radiate signals you can detect. It may live slowly underground, in oceans, in atmospheres, or in ways your definitions do not cover. Or it may have come and gone long before your kind appeared, leaving no trace but altered dust. But whether you find life elsewhere or not, you are already part of a cosmic lineage. The elements in your cells were forged in stars that lived and died long before Earth formed. The atoms in your bones may once have been part of comets, planets, or other organisms. The water you drink is older than the solar system. The dust beneath your feet is recycled starlight. Time will continue to pull everything forward. Stars will burn through their fuel. New ones will form from the remains of the old. Black holes will merge and eventually evaporate. Galaxies will darken as star formation slows. Planets will freeze or burn. Entropy will spread energy thin until nearly nothing remains but fading radiation and drifting matter. But that future is not your prison. You exist during the universe's bright middle, when stars still shine and galaxies still glow. You live when life is still possible and thought can still emerge. You are here in the fraction of cosmic history where the sky still tells the truth. And while you will not witness the end, your existence is no less a part of the story. You don't need eternity to matter. You need only awareness and presence in this moment of cosmic light. The universe is not waiting to remember you, it is already made of you. The universe is ancient, but not ageless. It has a timeline, a beginning, and a trajectory. You exist about 13.8 billion years after the first light, in a narrow window when stars are abundant, galaxies are bright, and complexity is still unfolding. You are not late to the story or early. You are exactly where physics has placed you. In the first instance after the universe began, matter and energy were indistinguishable. Space expanded faster than light, not by breaking rules, but by stretching the fabric itself. Temperatures were beyond comprehension, and particles formed and annihilated as quickly as thoughts flicker. As expansion continued, the universe cooled enough for quarks to combine into protons and neutrons. Minutes later, those particles fused into the first atomic nuclei, mostly hydrogen and helium, with traces of lithium. There were no stars yet, no galaxies, no light, except for radiation too hot to escape the dense fog of particles. For hundreds of thousands of years, the universe remained opaque. Light could not travel freely. It scattered constantly, trapped by energetic electrons. But as expansion continued and temperatures dropped, electrons finally bonded with nuclei to form neutral atoms. Suddenly, light could move unhindered. That light is still traveling now, stretched into microwaves by billions of years of expansion. It fills the cosmos in every direction, a silent memory of the moment the universe became transparent. Galaxies didn't appear immediately. Gravity gathered hydrogen and helium into vast clouds that slowly collapsed into the first stars. These stars were giants, hundreds of times more massive than the Sun, burning hot and fast. Their deaths were spectacular, exploding as supernovas that created the first heavy elements. Only then could the chemistry needed for planets and life begin. Over time, stars gathered into galaxies. Some formed as spirals, others as irregular clumps. The earliest galaxies were chaotic, colliding and merging as matter rearranged. The structures you see today are the descendants of those collisions. Every galaxy in the sky has a history of violence stitched into its shape. Your own galaxy, the Milky Way, formed from mergers of smaller galaxies and clouds of gas. Its spiral arms were shaped by gravity, rotation, and density waves. Its central bulge hides a supermassive black hole, millions of times the mass of the Sun. Stars orbit the center in vast loops that take hundreds of millions of years to complete. The Sun is on one such journey, having traveled less than a quarter of the way around since Earth formed. Earth itself came from debris left after the Sun ignited. Dust grains collided, stuck together, and grew into rocks and planetesimals. Some merged into worlds, others became asteroids and comets. The early solar system was chaotic. Worlds shifted positions, orbits crossed, and impacts were frequent. One such collision between a young Earth and a Mars-sized object created the Moon, a companion that stabilizes Earth's tilt and shapes the tides. Life began in conditions that would terrify you now: oceans of volcanic heat, skies filled with toxic gases, continents still forming. Yet chemistry found a foothold in that chaos. Molecules replicated, mutated, and adapted. Cells evolved. Life flourished in the sea first, then crawled onto land long after the planet cooled. Species rose and vanished in cycles longer than civilizations. Your existence is built on that unbroken chain, every ancestor surviving long enough to pass something forward. You are the outcome of cosmic history, planetary evolution, biological persistence, and accident. You are an extension of the same universe you try to understand, and understanding has revealed that everything you see is temporary. Stars burn through their fuel, galaxies drift apart, space continues to expand. One day, the night sky will go dark, not because stars die instantaneously, but because they run out of fuel and their remnants fade. White dwarfs will cool to black dwarfs over trillions of years. Neutron stars will slow their spin and fall silent. Black holes will evaporate through radiation so slowly the human mind can barely conceive the timescale. Eventually, only a thin glow of radiation and scattered particles will remain, stretched across an ever-expanding void. The universe will not end in fire, but in distance and silence. But that future is not your concern. You live in the bright era, when galaxies blaze and stars still burn. You can still see the traces of creation and the architecture of matter. You can still ask questions and build tools to answer them. You stand on a planet orbiting a stable star in a galaxy filled with light. You breathe air shaped by life, drink water older than the sun, and think with a brain built from elements born in dying stars. You are not apart from the universe. You are one of its brief expressions, aware enough to notice its scale. And this noticing is rare. The universe has existed for billions of years without witnesses. Stars ignited and died unseen. Galaxies collided without memory. Worlds formed and froze without eyes to observe them. If life exists elsewhere, most of it may never become aware of what it is. Consciousness is not the universe's goal. It is one of its experiments, yet here you are, thinking, remembering, imagining. You are the universe measuring itself for a moment before time erases the marks. And even if that moment is brief, it is not meaningless. Existence is not measured in permanence, but in presence. The night sky is a canvas painted with time. Every point of light you see has a story measured not in years, but in millions or billions of them. When you look at a star, you are seeing it as it was long ago. Some may already be dead, their light still on its way across the gulf of space. Others may be newly born, their glow just now reaching your eyes. The sky is not a portrait of the present, but a record of the past. Telescopes expand your vision far beyond the limits of sight. They reveal galaxies billions of light years away, so far that their light began its journey before Earth even formed. The Hubble Space Telescope captured images of galaxies so distant they are snapshots of the infant universe, tiny clusters of stars forming just a few 100 million years after the Big Bang. Future observatories extend this reach even deeper, into wavelengths invisible to your eyes, peeling back layers of cosmic history that light alone cannot show. But light is not the only messenger. Gravitational waves ripple through space-time when massive objects collide. Detectors on Earth are sensitive enough to measure distortions smaller than the width of a proton, catching the echoes of black holes merging billions of light-years away. These signals are vibrations in reality itself, carrying information about cataclysms no eye could see. With them, you are beginning to listen to the universe in a new way. Other particles arrive constantly. Neutrinos, born in the cores of stars and supernovas, stream through everything. Trillions pass through your body each second, unnoticed, undisturbed. They barely interact with matter, slipping through entire planets as if they weren't there. Yet with enough detectors and patience, you can catch them and learn what distant stars are doing in their hidden hearts. Cosmic rays, even more energetic, bombard Earth from galaxies far away, fragments of atoms accelerated to near light speed by explosions and magnetic storms in space. The more you look, the more you find that the universe is restless. Stars orbit the centers of galaxies. Galaxies orbit one another, clusters drift through superclusters, and all of it expands outward with space itself. Stillness is an illusion born of scale. Even your own planet hurtles around the sun, spins on its axis, and drags its atmosphere along with it. You feel grounded, but in truth, you are in constant motion. This motion has consequences. Earth's tilt changes slowly over tens of thousands of years, altering climate cycles. The shape of Earth's orbit shifts too, affecting how much sunlight reaches different regions. Over millions of years, these variations drive ice ages and warm periods. Even without human influence, Earth's climate is dynamic, guided by celestial mechanics written into its orbit. Yet life persists through all of it. It adapts to heat, cold, flood, drought, and extinction. It spreads into niches from boiling vents to frozen deserts, from acid pools to the upper atmosphere. Bacteria survive in conditions harsher than any human-built machine can endure. Tardigrades can survive in the vacuum of space itself. Life does not require comfort. It requires possibility. That possibility depends on balance. Too much radiation and molecules cannot survive. Too little energy and chemistry stagnates. Too much gravity and atmospheres collapse inward. Too little and they drift away. Earth exists in a delicate equilibrium, not perfect but sufficient. It balances rotation, tilt, distance, magnetism, and atmosphere in just the right way to sustain oceans and skies. And those oceans carry their own mysteries. The tides, pulled by the moon, have shaped the rhythm of life for billions of years. Currents carry heat across the globe, driving weather and climate. Deep trenches host ecosystems powered not by sunlight, but by chemical energy from the Earth's interior. Life there depends on sulfur vents and mineral flows, thriving in total darkness. These organisms remind you that biology is not fragile, it is inventive. The same creativity exists in the cosmos. Planets are inventive in their variety. Some are so close to their stars that their surfaces glow with molten rock. Some orbit two suns with skies of constant twilight. Some are made mostly of ice, hiding subsurface oceans beneath frozen shells. Some may be rich in diamonds, forged under crushing pressures of carbon. The diversity is endless, shaped by chance, chemistry, and gravity. Beyond planets, the structures grow stranger. Nebulae glow in colors sculpted by radiation and dust. Stellar nurseries lit by young stars carving paths through gas. Pulsars spin rapidly, flashing beams of radiation like lighthouses across space. Quasars shine brighter than galaxies, powered by matter falling into black holes. Magnetars release bursts of energy so strong they can outshine stars in an instant. The universe is a catalogue of extremes, a collection of phenomena that stretch your definitions. And yet, all of this, the galaxies, stars, planets, and even life, makes up less than 5% of the universe. The rest is dark matter and dark energy, invisible but undeniable. They shape the largest scales and dictate the ultimate fate. You cannot see them directly, but their fingerprints are everywhere, in the way galaxies move, in the way the cosmos expands, in the way structure forms. Your role is not to solve the entire mystery, but to recognize your place in it. You are made of ordinary matter, but ordinary matter is extraordinary in its possibilities. It can build atoms, molecules, cells, bodies, and minds. It can generate thought, memory, and curiosity. It can reach outward with machines and theories, asking questions of the darkness. And the darkness answers, not in words, but in signals, light, gravity, particles, patterns. It has no language but physics, and yet you've learned to translate it. Each answer opens new questions, and each discovery widens the horizon. You are not separate from the night sky. You are one of its expressions, a temporary arrangement of stardust wondering about its own origin. The fact that you can wonder is itself the most unlikely phenomenon of all. The universe is not silent. It speaks in forces and motion, in radiation and gravity, in the quiet persistence of expansion. Everything you see, every atom you touch, every breath you take is part of a system still unfolding from an origin older than planets, older than light itself. You are not outside of that process, you are a current within it. Gravity is the architect behind structure, but it does not work alone. Electromagnetism shapes atoms and allows chemistry to exist. The strong nuclear force holds protons and neutrons together. The weak nuclear force enables the fusion that powers stars. These four forces are the foundation of every physical phenomenon. from galaxies spiraling across space to neurons firing in your brain. The scale changes, but the laws do not. Your body is a temporary configuration of those forces. The atoms in you obey the same rules as the atoms in a nebula or star. You are built out of particles that were forged in the collapse and death of ancient suns. Even the simplest cell in your body is the consequence of physics working through chemistry over billions of years. Life is not separate from the universe. It is one of the ways the universe expresses itself. Stars, the engines of creation, are not eternal. They form when clouds of gas collapse under gravity. As they shrink, pressure and temperature climb until hydrogen atoms fuse into helium, releasing energy. That energy pushes outward, balancing gravity's pull. A star shines because it is constantly on the edge of collapse, held up by the fusion in its core. When its fuel runs out, gravity wins. Small stars, like red dwarfs, sip their hydrogen slowly and can burn for tens of billions of years. They are dim and common, quietly illuminating the universe. Larger stars live fast and die young. They fuse heavier elements in later stages, creating carbon, oxygen, silicon, and iron. When fusion can no longer continue, the core collapses, triggering a supernova, an explosion so bright it can outshine entire galaxies for a moment. The elements blasted into space become seeds for future stars, planets, and eventually life. Black holes are the remnants of the most massive stars. When their cores collapse, not even light can escape their gravity. But they are not cosmic vacuums devouring all around them. They sit in space-time like pits in a stretched fabric, shaping the orbits of stars and gas. Some power quasars, beacons so bright they pierce the early universe. Others drift quietly, invisible except for the motion of what surrounds them. Even more ancient than stars are the relics of the Big Bang that still fill space. The cosmic microwave background is the faint afterglow of the universe's birth, stretched into microwaves by billions of years of expansion. It is nearly uniform across the sky, with tiny variations that seeded the formation of galaxies. Measuring it is like listening to a heartbeat from the beginning of time. Expansion continues, driven by dark energy. Galaxies that are distant now will, in time, move beyond the edge of observability. Light from them will never reach you. The cosmic horizon is not a wall, but a limit, one that grows as space expands. There are places in the universe you will never know existed, simply because their light will always be too late. Yet even within that limit, you see staggering diversity. Some galaxies are orderly spirals, their arms glittering with young stars. Others are chaotic, shaped by collisions or stripped by gravity. Some have active cores that spit jets of energy across interstellar distances. Others are fading, their star-making gas depleted, their light slowly dimming into infrared and silence. Between these galaxies lie voids, vast regions with almost no matter, where a traveler could cross millions of light years without passing a single star. But even voids are not empty. They contain dark matter, lonely particles, and the stretched light of ancient radiation. Emptiness, like stillness, is an illusion of perception. At smaller scales, planets and moons offer their own dramas. Some are molten worlds with rivers of lava. Others are frozen, with oceans locked under crusts of ice. Gas giants swirl with storms larger than Earth, their atmospheres layered in colors born of chemistry and pressure. Rocky planets vary wildly, some scorched by proximity to their stars, others tidally locked with one face in permanent night and the other in endless day. And among these worlds, life may be hiding in forms unimagined. It might swim under alien oceans or cling to minerals in subterranean caverns. It might drift through atmospheres or hibernate in ice. Life is not obligated to resemble Earth's biology. It is obligated only to obey physics and adapt to conditions. But even if life is rare, the ingredients are not. Water, carbon, and complex molecules exist in nebulae, comets, and interstellar dust. Organic compounds form in the cold between stars. Meteorites that fall to Earth have carried amino acids and sugars older than your planet. The chemistry for life permeates the cosmos, waiting only for conditions that allow it to assemble. You are one such assembly, a network of cells powered by the same energy that drives stars, built from atoms as old as time. You witness the universe not from above, but from within, as one of its passing arrangements. The universe does not ask you to understand it. It continues whether you do or not. But it allows you the capacity to try, and that capacity is its rarest phenomenon. You are surrounded by forces that shaped galaxies, and you use those same forces to think, build, and reach beyond your cradle. Your awareness is a flicker in cosmic time, but a flicker can illuminate. You are not here to outlast the universe. You are here to experience the part of it that burns before the dark. And that is enough. You live inside a universe defined by contrast. Darkness gives shape to light. Silence makes motion visible. Emptiness outlines structure. Without the void, there would be nowhere for galaxies to form, no stage for stars, no canvas for existence. The space between things is not absence. It is the medium through which everything moves and becomes. Interstellar space is not empty. It contains atoms, dust, and radiation stretched thin across light years. A single cubic meter may hold just a few particles, but over distances measured in trillions of kilometers, those particles gather into clouds that birth stars. Nebulae look ghostly from afar, but up close they are factories of formation, where gas collapses under gravity into spheres hot enough to ignite. Some clouds glow from starlight hitting dust. Others shine from within, lit by newborn stars still wrapped in the remnants of their birth. Not all stars live quiet lives. Some pulse in periodic rhythms, expanding and contracting as if breathing. Others flicker rapidly due to spots, flares, or rotation. Binary stars orbit each other in slow dances or violent spirals, trading matter until one explodes or both merge. Some are devoured by their partners, forming accretion disks that glow in X-rays. Others collapse into white dwarfs, dense remnants that can be the size of Earth but hold more mass than the Sun. When white dwarfs pull in too much matter from a companion star, they can explode as supernovas, releasing more energy in a moment than the Sun will emit in its entire lifetime. These explosions spread heavy elements across galaxies, seeding future systems with the raw material of planets and bodies. Even the calcium in your bones and the iron in your blood were born from such detonation. Neutron stars emerge from even greater collapse. They are so dense that a teaspoon of their material would weigh billions of tons. They spin rapidly, some rotating hundreds of times per second, sweeping beams of radiation that can be detected across space. These pulsars are some of the most precise natural clocks in existence. Their timing so consistent that even slight irregularities reveal the presence of orbiting planets or passing gravitational waves. Black holes form from collapse beyond measure. Their gravity bends space so steeply that not even light can escape once it crosses the event horizon. Yet black holes do not simply consume, they influence. They anchor galaxies, drive jets of matter across light years, and shape the orbits of stars. Some black holes are so massive they could fit millions of suns within their radius. Yet they began as stars like any other, changed only by mass and time. But even black holes are not infinite prisons. They evaporate through Hawking radiation, losing energy over timescales so vast they defy comprehension. Matter that falls into them is not destroyed in the traditional sense. It is transformed and its information stretched to the edge of physics. Black holes are the final editors of mass in a universe that wastes nothing. Between stars, planets orbit with their own destinies. Some systems are orderly, with circular paths and stable distances. Others are chaotic, with tilted orbits, crossing trajectories, and worlds flung into interstellar space. Rogue planets wander the galaxy without stars, their surfaces frozen or warmed only by internal heat. Gas giants may migrate inward after formation, disrupting smaller worlds or swallowing them whole. Moons may harbor oceans beneath layers of ice stirred by gravitational flexing. You look for life on planets that feel familiar, Earth-like in size, distance, and chemistry. But the universe is not obligated to repeat the same pattern. Life could form in methane lakes, ammonia seas, or subsurface oceans untouched by sunlight. It could bloom in atmospheres thick with carbon dioxide, or under crusts where volcanic vents provide energy. It could be microbial, plant-like, or something beyond your metaphors. You search with instruments tuned to what you know, but what exists may exceed your imagination. Even silence can mislead. A planet may thrive with life, but never produce radio signals or visible structures. A civilization may exist, but choose not to speak, or may speak in ways undetectable to you. They might send messages across time instead of space, encoded in matter or written into the physics of particles. They might rise and vanish before their light reaches you. The absence of evidence is not evidence of absence. It is evidence of limitation. Your own signals have just begun their journey into space. They travel outward at light speed, passing stars one by one. The oldest are less than a century old, meaning they have only crossed a fraction of your galactic neighborhood. Most of the galaxy does not yet know you exist, and you may never know if anyone hears you. Communication across stars is not conversation. It is archaeology projected forward. Yet you listen. You point radio telescopes at the sky, scanning for patterns too precise to be random. You study atmospheres of exoplanets for signs of imbalance that chemistry alone cannot explain. You simulate the possibilities of life in environments harsher than any on Earth. You refuse to assume that thought happened only once. But even if life elsewhere never announces itself, you remain part of the same phenomenon. The particles in your body have drifted through space for billions of years before assembling into you. They will drift again when you are gone. The water you drink came from comets, ash, rock, and vapor recycled over eons. The heat in your body was once starlight. Awareness is temporary, but matter endures. Thought fades, but energy persists. Your existence is not a break from the universe. It is a translation of its rules into consciousness. You think because atoms allow it. You wonder because forces permit it. You belong because you are made of the same story you are trying to read. The universe will continue long after your voice is quiet, but while you exist, you are part of its illumination, not as an observer outside of it, but as one of its sparks, rising briefly in the dark. The universe is a continuum of transformation. Nothing that exists stays in its original form. Not stars, not planets, not galaxies, not even space itself. Everything changes state over time, guided by gravity, radiation, and entropy. Even atoms, which feel permanent to you, are temporary arrangements built on probabilities and decay. Galaxies evolve through collision and consumption. When two galaxies merge, their stars rarely collide directly because of the vast distances between them, but their gas clouds do. Those impacts ignite bursts of star formation, lighting regions that were once dormant. Black holes at the galactic centers can flare to life, feeding on matter and releasing jets that span thousands of light years. Over millions of years, the chaos settles into a new structure, bigger, altered and etched with the memory of destruction and creation. Stars are the universe's alchemists. Their cores are crucibles where hydrogen fuses to helium and later into carbon, oxygen, silicon, and iron. But once fusion reaches iron, energy can no longer be gained by compression. The core collapses and the star's outer layers explode outward. These materials scatter across space, binding to dust, gas, and gravity. When new systems form, they inherit the enriched elements. Without those ancient deaths, planets with rock, metal, and carbon-based life could not exist. Planetary systems also reshape over time. A world's orbit can change due to gravitational nudges from neighbors. Moons can drift inward or outward. Asteroids collide and fragment. Comets from distant reservoirs fall inward toward stars, their tails evaporating in arcs of ice and dust. Entire planets can be ejected from their systems, becoming wanderers through interstellar space. Nothing remains fixed just because you observe it in a moment of stability. Even your sun is on a journey. It began as a dense knot in a molecular cloud, ignited and cleared its surroundings. It will shine for billions more years, slowly growing brighter over time. Eventually, Earth's oceans will boil away, long before the sun expands into a red giant. When that day comes, the inner planets may be swallowed or stripped to their cores. What remains will drift in orbit around the white dwarf that replaces the sun. Life, too, evolves through transformation. The earliest cells on Earth would not survive in the atmosphere you breathe today. Oxygen, now essential to most complex organisms, once threatened nearly all life. Mass extinctions repeatedly erased dominant species, clearing paths for new forms to diversify. Catastrophe and adaptation are inseparable threads in the story of survival. You exist in a brief equilibrium, long enough for life to flourish, short enough to feel stable. But that stability is an illusion built on motion. Tectonic plates move beneath your feet. The magnetic field shifts around you. The moon drifts farther away each year. The continents migrate like slow ships across the mantle. Even the air changes, shaped by volcanoes, sunlight, oceans, and the breath of living things. The atoms in your body were once in stars, dust clouds, oceans, and other organisms. They will return to those states again. You are not a closed system. You are a temporary pattern through which matter flows. The universe does not stop to commemorate these transitions. It continues them endlessly. And in the middle of this motion, you witness a fraction of the timeline, aware not only that things change, but that you are made of change. Awareness does not halt transformation. It illuminates it. What you see as permanence is simply transition, slowed enough for you to hold it in memory. The universe moves on timescales so vast that human perception can barely register them. Stars are born, live, and die over millions or billions of years. Galaxies collide and merge across spans longer than Earth has existed. Even the light that reaches your eyes has often traveled longer than your species has walked upright. You experience only a sliver of this motion, yet you live inside it completely. Space itself is not static. It stretches in all directions, carrying galaxies with it. The farther away a galaxy is, the faster it appears to recede. This expansion began shortly after the universe was born and has accelerated over time due to dark energy, an unseen force that works not by pushing on matter but by acting on space-time itself. One day, most galaxies will slip beyond the observable horizon, receding so quickly that their light will never reach you. But not everything is driven apart. Local groups of galaxies remain bound by gravity, resisting expansion on smaller scales. The Milky Way and Andromeda are moving toward each other and will merge in a few billion years. Their stars will swirl into new shapes, and their central black holes may collide. The planet you stand on may not exist by then, but the universe does not measure time by your calendar. Even on Earth, cosmic influence is constant. The planet is shielded by its atmosphere and magnetic field, but not fully. Solar wind and cosmic rays still reach the surface. They alter molecules, shift electrons, and occasionally change DNA. Some mutations harm, others enable adaptation. Life evolves partly because the universe keeps touching it. Cosmic dust lands on Earth every day, fragments of asteroids, comets, and ancient stars. Some of it dissolves in oceans and becomes part of the chemical cycle. Some settles into rock layers, recording eras of bombardment or calm. Over millions of years, continents swallow and exhume these layers, hiding and revealing traces of impacts that once shook the sky. Looking upward, you see a sky that appears permanent, but it too is changing. Stars drift relative to one another. Some move so fast they will leave the galaxy entirely. Others will one day pass close enough to perturb the solar system's comets or alter planetary orbits. The constellations will warp into new shapes, but only over spans longer than human history endures. The Moon, your constant companion, is also retreating. It drifts away from Earth by a few centimeters each year. Long ago, it appeared much larger in the sky and caused stronger tides. Far in the future, eclipses will no longer occur because the Moon will appear too small to cover the Sun. The rhythm of tides will slow, altering coastlines and ecosystems. Yet to your senses, it feels eternal. Human thought struggles with these scales because your biology evolved for immediate survival, not cosmic perception. You measure time in heartbeats, seasons, generations, not in stellar lifetimes or galactic rotations. Yet your tools extend your awareness. Telescopes let you see the past. Equations let you predict the future. You have built ways to step outside your narrow window of experience and watch the universe as it was, is, and will be. And in doing so, you've discovered that impermanence is not loss, it is process. Stars die so others can form, moons drift so tides evolve, galaxies merge so structures grow, worlds shift so life can change. Nothing is wasted because nothing is final. You are not separate from that flow. You are a temporary expression of ancient matter in motion. The atoms in your body have belonged to stars, dust, oceans, and organisms before. They will belong to others after. What feels like identity is a brief arrangement of universal material experiencing itself. To exist is to participate in transition. The universe is not organized for your convenience, yet you've learned to read its structure. You map the sky not because it needs mapping, but because your mind seeks pattern. Constellations were once navigation, then myth, then curiosity. Now they are waypoints for telescopes that scan millions of light years beyond their shapes. The sky you name is only a fraction of what exists, and most of what exists is invisible. Dark matter weaves the cosmic web, forming halos around galaxies and clusters. It doesn't shine or absorb light, but it dictates motion. Stars near the edges of galaxies orbit too quickly to be held by visible matter alone. Something massive surrounds them, unseen but undeniable. Without dark matter, galaxies would never have formed. The Milky Way itself sits inside a vast halo of it, extending far beyond the reach of its stars. Dark energy is stranger still. It drives the acceleration of expansion across the universe, overpowering gravity on the largest scales. You don't feel it, but it stretches the space between galaxy clusters. It may determine the ultimate fate of everything. If it continues to accelerate, galaxies will drift apart until each becomes isolated, alone in a darkening void. Light from beyond will fade, leaving only local stars to mark existence. You live in the era when the universe is still bright. Stars burn, galaxies collide, and nebulae glow. The night sky still carries the memory of its beginnings, painted in microwaves and red-shifted light. You can detect the afterglow of the Big Bang and trace the structure of matter across billions of years. This visibility will not last forever. The deeper future will erase the evidence you rely on now. Yet even now, light hides more than it shows. Black holes bend it. Dust scatters it. Distance drains it. Some regions of the universe are blocked by gas clouds or glare. Others are so far that their light has stretched into wavelengths difficult to detect. You build instruments to see beyond your eyes, infrared telescopes to pierce dust, radio arrays to map hydrogen clouds, X-ray observatories to catch the heat of violent collisions. What you see reveals both order and chaos. Galaxies gather in clusters, connected by filaments of matter. Between these filaments lie voids so empty that a traveler could cross millions of light years without encountering a star. On smaller scales, stars collect into systems with planets, moons, and asteroid belts. Some systems are stable, others are dynamic, shaped by resonance and chance. Worlds themselves reflect the universe's variety. Some orbit in hours, others in centuries. Some are scorched so intensely their atmospheres boil away. Others are buried in ice beneath which oceans hide. Gas giants may have rocky cores or none at all. Super-Earths and mini-Neptunes blur your categories. Moons can rival planets in size or exceed them in habitability. And yet, amid all this diversity, the same physics prevails. Gravity shapes orbits, heat drives weather, radiation alters atmospheres, chemistry builds molecules from common elements: hydrogen, oxygen, carbon, nitrogen, silicon, iron. The ingredients for planets and life are not rare. They are widespread across nebulae, comets, and dust clouds. Life requires only complexity and stability long enough to adapt. Earth has provided that for billions of years, but not without interruption. Impact events, volcanic winters, and ice ages nearly reset the planet more than once. Each time, life recovered and diversified. Intelligence was not guaranteed. It emerged because conditions allowed it, not because the universe intended it. You now use that intelligence to send machines across the solar system and signals into space. You look for worlds like your own and signs of life beyond. You search atmospheres for oxygen, methane, and other traces of biology. You listen for patterns that might indicate thought. Nothing has answered yet, but silence is not proof. The universe does not hurry. Communication across stars may take centuries. Recognition may take millennia. Discovery may come long after you're gone. But the search itself is part of your nature, born of atoms that once drifted in silence and now ask questions of the night. You do not need the universe to respond to know you belong to it. The Earth feels like the center of your experience, but it is not central to the universe, only to your perception. From space, it is a small sphere wrapped in a thin film of air, lit on one side and shadowed on the other. Its surface shifts constantly, oceans moving, continents drifting, clouds forming and dissolving. Even the ground beneath you is temporary, made from older surfaces buried and uplifted over eons. The atmosphere that sustains you is a fragile skin compared to the planet's scale. It holds heat, cycles water, filters radiation, and carries the breath of every living thing. But it is also shaped by forces beyond Earth, solar wind, cosmic rays, and the slow changes in the sun's brightness. Oxygen, which you depend on, was once a toxin to early life. It built up over time because photosynthetic organisms altered the air. The sky you see is not original, it is inherited. Water, too, is ancient. The oceans likely formed from a mix of volcanic steam and cometary ice. They have risen and fallen, frozen and evaporated, carried elements from rock into life and back again. Every drop you drink contains molecules older than the planet itself, recycled through cycles longer than history. Rivers carve canyons over millennia. Glaciers grind mountains into silt. Rain reshapes landscapes grain by grain. Earth orbits the sun in a zone where temperatures allow liquid water, but that balance is delicate. A slight shift in orbit, tilt, or solar output could freeze or boil the oceans. Other planets in the solar system tell you how narrow the margins are. Venus was once Earth-like, but runaway greenhouse effects turned it into a furnace. Mars lost much of its atmosphere and magnetic field, allowing its water to evaporate or freeze. Both were possible worlds, only one remained hospitable. Yet even habitability does not guarantee survival. The sun's brightness will continue to increase over time. In less than 1 billion years, Earth will likely become too hot for complex life. Long before the sun becomes a red giant, the oceans will vanish and the atmosphere will change. The planet will remain, but its surface will be hostile, its biosphere gone. The solar system itself is dynamic. Asteroids and comets still cross planetary paths. Impacts shaped Earth's history and will shape its future. Some carry water and organics, others bring devastation. Jupiter's gravity both protects and threatens, capturing or deflecting objects, but sometimes redirecting them inward. The balance of risk is constant. Beyond the planets lies the Kuiper Belt and the Oort cloud, vast reservoirs of icy bodies left over from formation. Some may not have moved in billions of years. Others drift slowly toward the sun, their journeys taking millions of years. They are relics of a time when the solar system was chaotic and violent, when collisions were constant and orbits unstable. Every world you see, near or distant, began in that same disorder. Order emerges not from calm, but from conflict, gravity sculpting chaos into orbits and systems. What appears stable now is the outcome of eons of collision, destruction, and absorption. And even after planetary systems settle, stars move through the galaxy. In millions of years, the night sky will feature entirely different constellations. In hundreds of millions, other stars may pass close enough to disturb cometary clouds or alter planetary orbits. The sun itself follows a path through spiral arms, drifting in and out of regions where supernovae and radiation are more common. These motions take place on scales far beyond human lifespans, but they are not less real. Your existence is layered atop processes that began before you and will continue long after. You are not separate from those timelines. Your life is woven into them, even if you only witness a flicker. To live is to stand briefly in the river of cosmic change and notice the current. Human beings evolved to navigate forests, plains, and coastlines, not galaxies. Yet you've learned to read the universe with tools and thought. Your senses detect only a narrow slice of reality. Visible light, sound in air, moderate temperatures, and familiar scales. You do not see atoms, nor perceive the curvature of space, nor feel time dilation. But curiosity extends beyond biology, and so you build instruments that translate the invisible into something you can comprehend. Radio telescopes capture signals from hydrogen clouds, pulsars, and distant galaxies. Infrared observatories reveal stars in formation buried in dust. X-ray instruments detect black holes ripping gas from companion stars. Gravitational wave detectors listen for space-time ripples from cosmic collisions. These machines give you new senses, not by changing your body, but by extending your reach. You've mapped the structure of the Milky Way, even though you cannot step outside it. You've determined the universe's age from the glow of the cosmic microwave background. You've found planets orbiting stars hundreds of light years away by measuring dimming no eye could see. You've measured the speed of expansion across billions of years using supernovas as markers. You've turned photons into history. Even time, which feels constant to you, is elastic. Clocks on GPS satellites tick faster than clocks on Earth because gravity affects time. Objects moving at high speeds experience time slower than those at rest. These effects are not theories. They are measured and corrected for daily. Without acknowledging relativity, your navigation systems would fail. Reality does not adjust to intuition. Intuition must adjust to reality. Space is also not flat. Massive objects bend it, and light follows those curves. A galaxy cluster can act like a lens, magnifying a more distant galaxy behind it. You can see multiple images of the same object due to gravitational lensing, its light taking different paths through warped space-time. These distortions let you observe galaxies too faint or distant to detect otherwise. At even smaller scales, quantum mechanics governs. Particles behave as both waves and points. They do not have definite positions until measured. They can tunnel through barriers that classical physics says they should not cross. Pairs can become entangled, influencing each other instantly over any distance. The world beneath perception is stranger than any model designed for survival. Yet despite this strangeness, you harness quantum rules. You use semiconductors built on electron behavior. You create lasers using photon coherence. You build atomic clocks whose precision relies on transitions inside atoms. You develop quantum computers by exploiting superposition and entanglement. Physics that defies common sense still powers your world. Your understanding is not complete. You do not know how to unify gravity with quantum mechanics. You do not know what dark matter is made of. You do not know the true nature of dark energy. You do not know whether the universe is finite or infinite, or whether it had a cause beyond itself. But ignorance does not diminish existence. It defines the frontier of discovery. You are a momentary configuration of matter, aware of its impermanence yet driven to explore. The universe does not require your understanding to exist, but your understanding is one of the universe's rarest phenomena. You are not separate from the cosmos you study. You are its experiment in self-awareness. When you look into the night sky, you are not seeing the universe as it is, but as it was. Light travels at a finite speed, and distance is time. The moon you see is over a second old. Sunlight takes 8 minutes to arrive. Light from the nearest star is 4 years in transit. The glow of distant galaxies began its journey before humans existed. The deeper you look, the further back you peer into history. Telescopes are time machines, not because they alter time, but because they reveal it. The cosmic microwave background is the oldest light you can detect, a relic from when the universe was young and hot. It has stretched and cooled over billions of years, but it still carries imprints of the earliest fluctuations in matter and energy. Those tiny variations became the structure of galaxies, clusters, and filaments. The universe began smooth, but not perfectly so, and those imperfections became everything. You are also limited by the horizon of what can be observed. Beyond a certain distance, space expands faster than light can cross. There may be regions of the universe you will never see, no matter how long you wait. Not because they do not exist, but because reality outruns visibility. The observable universe is not the full universe. It is only the part whose light has reached you. And while you reach outward with telescopes and probes, the universe also reaches inward. Neutrinos from the sun and distant supernovas pass through your body by the trillions every second. Cosmic rays strike the atmosphere and generate showers of particles that fall to the ground. Radio waves from pulsars and quasars wash across Earth without permission. You are bathed in signals you do not feel. Even gravity connects you to stars and galaxies. Every mass in the universe exerts a pull on every other. The influence weakens with distance, but it never vanishes. The path of Earth around the Sun is shaped by Jupiter, the Moon, and even the distant tug of the galaxy's core. Your body is technically influenced by stars whose light you will never see. Connection is not always visible. Scale blinds you. You think of planets as large, yet Earth is a speck next to Jupiter, which in turn is tiny beside the Sun. The Sun is dwarfed by red giants and hypergiants. Those giants are trivial compared to galaxies, and galaxies are grains of dust in the superclusters that stretch across cosmic filaments. Even those filaments are not endpoints. They are merely features in something larger, shaped by forces you still try to name. And yet, scale does not determine significance. A supernova and a strand of DNA both obey the same physics. A black hole and a neuron both shape and respond to energy. A galaxy and a human mind both emerge from the same fundamental rules. The universe expresses itself at every level, not only in the vast, but in the minute. Your awareness is not outside the cosmos. It is an event within it. The atoms in your brain once drifted through stars, dust, gas, and rock. They were shaped by fusion, decay, collision, and time. Now they form thoughts that reach across light years in concept, if not in distance. The universe gave rise to something that contemplates its origin. You do not witness the whole, but you are part of the whole. What you see is limited. What you are is not separate. Existence is not only around you, it is within you, as you. To observe the universe is to observe yourself in another form. The universe is not obligated to make sense to you, yet you keep shaping meaning from its immensity. You give names to galaxies, catalogue stars, and track comets across the sky, because comprehension is your way of participating in existence. You are surrounded by phenomena vast enough to erase you, but instead of retreating, you study them. Curiosity is not survival-driven alone. It is an echo of the universe turning its gaze inward. Throughout history, you mistook the sky for a dome, the stars for lanterns, the earth for the center of all. Slowly, observation replaced assumption. You learned that the earth orbits the sun orbits the galaxy's center, and the galaxy moves through a larger structure. Position is relative, and your place is not central but connected. Every discovery removed you from the center, yet deepened your connection. You are not the focal point of creation, but a fleeting outcome of its processes. The same forces that shaped galaxies shaped the atoms in your hands. You are not separate from the story, you are part of its unfolding. You once believed the universe was static, infinite, and eternal in its current form. Then you found it expanding. You thought the Milky Way was everything. Then you detected galaxies beyond counting. You imagined the cosmos was calm. Then you discovered supernovas, quasars, black holes, and gamma-ray bursts. Each revelation widened your view and humbled your assumptions. Even now, your understanding is incomplete. You do not know what existed before the Big Bang, if before even applies. You do not know whether the universe is one of many or part of a cycle. You do not know if time has an end or transforms into something unrecognizable. What you know is a fraction of what is true, and still you reach. Science is not a list of answers. It is a method of asking better questions. You measure light to learn distances. You analyze spectra to decode composition. You detect wobbles in stars to infer planets. You map background radiation to glimpse the universe's earliest state. You use gravitational lensing to reveal dark matter. You detect space-time ripples to hear collisions that happened billions of years ago. every tool is an extension of your will to understand. And that desire is not trivial. Consciousness, as fragile and temporary as it is, grants the universe a witness. Stars burn whether you see them or not, but awareness transforms existence into experience. A galaxy without observers is still majestic, but a galaxy seen, studied, and wondered at becomes part of mind as well as matter. You are not the universe's purpose, but you are one of its outcomes. If consciousness had not emerged, the cosmos would still expand and collapse, but no patterns would be named, no stories told, no questions formed. Your curiosity is not cosmic necessity, it is cosmic possibility. You will not solve everything in a single lifetime, nor in a million. But each observation, each insight, each correction is a step in a journey that exceeds individual existence. Knowledge is cumulative. The truths uncovered by ancient astronomers led to telescopes, equations, and spacefaring machines. The questions you ask now may one day guide beings who live beneath different stars. You stand briefly in a universe that existed long before you and will continue long after. But in your moment, you give it reflection. You often think of the universe in terms of what is visible, but most of reality lies outside your senses. You cannot see infrared without instruments, yet stars and planets glow with it. You cannot detect ultraviolet, yet it shapes atmospheres and scars skin. You cannot hear the low hum of plasma waves or feel the cold emptiness between galaxies. What you call nothing is often something you have not yet learned to perceive. Dark matter does not emit or absorb light, but its gravity sculpts the cosmos. You know it exists because galaxies rotate too quickly for visible mass alone to hold them together. Clusters of galaxies bend light, passing behind them, revealing hidden mass that outweighs stars and gas. Dark matter forms the scaffolding upon which galaxies assemble, threading the universe with invisible structure. Dark energy is even more elusive. It does not clump or gather. It acts everywhere, stretching space itself. It accelerates expansion, driving galaxies apart faster over time. If it continues unchanged, the cosmic web will unravel. Future observers, far ahead in time, may see only their own galaxy, unaware that others ever existed. You live in a rare period when the universe is still legible. But invisibility does not imply absence. Air is unseen, yet you breathe it. Gravity has no color, yet you feel its pull. Magnetism cannot be touched, yet it shapes star formation and planetary fields. Neutrinos pass through Earth as if it were not there, and still you detect them in buried tanks of fluid and light sensors. The universe hides its workings in layers, but those layers can be peeled. Even memory is written into matter. The iron in ancient meteorites records the magnetic field of the solar system's birth. The isotopes in ice cores preserve the breath of ancient atmospheres. The light from distant galaxies encodes the rate of expansion and the density of matter. The cosmic microwave background holds the map of initial fluctuations that became stars and worlds. Time leaves signatures, even when witnesses vanish. You search not only for what is, but for what was. You study craters to learn of impacts, fossils to learn of life, and starlight to learn of origins. You reverse entropy in thought, reconstructing events from scattered traces. A supernova that exploded before humans existed can still be dated and modeled. A galaxy formed billions of years ago still sends light into your telescopes. The past is not gone, it is delayed. And still, you accept that much will remain unknown. There are stars whose light will never reach you because they lie beyond the horizon of observation. There are particles that decay before you can detect them. There are processes too slow or too subtle to witness directly. Ignorance is not failure, it is the frontier. Mystery is not a barrier, but a landscape. You are not meant to solve existence in one era. You are meant to explore, revise, and continue. What you cannot find today may be discovered by minds not yet born, using tools not yet imagined. The universe does not grant you certainty, it grants you possibility. You are not separate from the unknown, you are woven into it, built from matter that still surprises you. To wonder is not to lack knowledge, it is to recognize that reality exceeds conclusion. The universe will not remain as it is. Stars will exhaust their fuel, galaxies will dim, and matter itself will undergo transformations that span trillions of years. The night sky you see now is temporary, a phase in a timeline so long that even imagination strains to hold it. Yet its fate is not an erasure of meaning, but a continuation of process. The end of one era is the beginning of another. In the far future, star formation will slow as gas is consumed or lost. Fewer new stars will ignite, and those that remain will age and fade. Red dwarfs, the most common and longest-lived stars, will burn their fuel over trillions of years. They will outlast suns and giants, shining dimly in a universe growing darker. Planets orbiting them may remain illuminated long after brighter stars are gone. White dwarfs will cool into black dwarfs, silent remnants of stars that once burned with fusion. These objects will still hold mass, shaping gravity, but they will no longer shine. Brown dwarfs, failed stars, will drift as faint embers. Neutron stars and black holes will persist, the compact leftovers of stellar death. The galaxy will become a graveyard of remnants orbiting in silence. Yet even in that distant age, collisions will happen. Brown dwarfs may merge and briefly ignite. White dwarfs may encounter enough matter to flare in explosions. Black holes will continue consuming gas, dust, or stars that wander too close. Gravity does not rest simply because light fades. Over unimaginable timescales, galaxies themselves will collide and merge. The Milky Way and Andromeda will combine into a single system, sometimes called Milkdromeda, reshaping their stars and black holes. Other galaxies in the local group will join the merger. Farther away, expansion will carry other galaxies beyond reach, their light fading into silence. Eventually, even black holes will not endure forever. They will lose energy through Hawking radiation, shrinking slowly over eons. The largest will persist the longest, but time will erode them too. When they vanish, their mass will be released not in flame, but in a final whisper of particles. No object is immortal, only change is. What remains in the far future may be a thin haze of particles drifting through cold space. Protons may decay, or they may persist. Electrons may pair with positrons or detach into the void. Space may continue expanding, or dark energy may shift and alter the outcome. You do not yet know whether the universe will freeze, collapse, fragment, or transform into something beyond comprehension. But none of these fates diminish what has occurred. Stars lived and died. Planets formed and shattered. Life arose on at least one world. Thought emerged briefly and considered its own impermanence. The universe does not require permanence for significance. Existence itself is its testament. You live in a rare moment when light still fills the sky, when galaxies are still visible, when stars are still forming, when life is still possible. You stand in the middle of a story whose beginning you trace and whose end you will not see. Yet your awareness gives this moment shape. To exist now is to witness the universe in its luminous age before darkness reclaims the horizon. You are a transient form in a vast unfolding, but transience does not erase meaning. The universe does not pause for your awareness, yet your awareness is one of its rarest expressions. You are composed of ancient atoms arranged for a brief moment into thought, memory, and perception. When that arrangement dissolves, those atoms will continue their journey through stars, dust, and time. You are not separate from the cosmos. You are one of its temporary configurations. Life on Earth arose not because the universe intended it, but because the conditions allowed it. Over billions of years, matter organized into chemistry, chemistry into cells, cells into organisms, and organisms into complexity. You are the result of unbroken continuity, stretching from the first replicating molecules to the present moment. The same forces that sculpt galaxies sculpted you, not as a destination, but as a phase. Awareness gives you the ability to look outward and inward. You can trace your origins to the cores of stars and the dust of nebulae. You can imagine futures that extend beyond your lifetime, and civilizations that may rise after yours is gone. The scale of existence dwarfs you, but it also includes you. You are not looking at the universe from outside. You are one of the ways it sees itself. Meaning is not assigned by the cosmos. It is created by those who experience it. A supernova has no more inherent meaning than a heartbeat, but a mind can connect both as part of a single story. You invent narratives to make sense of immensity, not to diminish it, but to participate in it. To tell the story of the universe is to acknowledge that you are inside it. You live in a moment when stars still shine, when galaxies still gather, when matter has not yet thinned into silence. You have the tools to observe the past and imagine the future. You can hold both your insignificance and your intimacy with existence in the same thought. You are small, but you are not separate. Even when the universe grows dark, its history will not be undone. The light that once traveled, the stars that once burned, the worlds that once turned, all will have been real. Existence does not require permanence to matter. Moments are not less significant because they end. You do not need eternity to justify experience. You are part of a cosmos that has existed for billions of years and will continue long after you are gone. Your role is not to outlast it, but to witness it while you can. Awareness is not a defense against impermanence. It is a response to it. The universe will continue long after the last star fades, long after memory itself becomes impossible. But in this fleeting era, you see its brilliance. You walk on a planet lit by fusion, breathing air shaped by ancient life, made of atoms older than your world. You feel wonder not because the universe is yours, but because you are its. Everything you are will return to the fabric from which it came. The particles that think these thoughts will one day drift in darkness, waiting to become something else. That is not loss. It is continuity. To exist is to be a moment of the universe noticing itself before the night resumes.